Hi everyone, thanks for listening this message. In recent times, we got messages that do we have any program, any course where we can go enroll and we will be very much eligible for the job market. What does it means that if you go and check the IT portals, you can see that you have different course packages for CCNA, then CCNP, then firewall, then cloud, then automation, etc. Right? So what we have done that we created one program for those engineers who want everything at one place and they are new to the market, or maybe they want to enhance their skill set. So we created such program, Joint. Joint is something like job-oriented internetworking training. Now, in this program, you can see that we have added CCNA routing switching, cloud virtualization part of VMware, CCNA or associate level wireless knowledge, Cisco Meraki, Google Cloud associate level knowledge, not entire course, but how much you need um, to get clear in your interview, or when you are working on this cloud environment, you are not new to that cloud environment. Then Python, then routing switching, ASA firewall, and then we are adding firepower as well. So not only ASA firewall, but next generation firewall. Then we are going to add Cisco SD-WAN, Cisco DNA, etc. Like what we want, that we want to make this course as a complete package course, in terms that once you go and complete these areas, you write, you can write in your profile, in your CV, that you know these technologies. And apart from that, not only this course, once you go and use the Joint 9, that's the code here, and if you apply, you will get maximum 85-86% discount on this course. So not only that we are offering the discount coupon, but apart from that, we are giving the lab, EVNG lab. So whoever will go and join this particular course, they will go and get the EVNG lab as well, so they can practice routing switching, right? So what you need a solid foundation, solid course where you can gain the technology knowledge. Then you need the lab environment where you can go and do hands-on practice. And then you can go and add these areas in your profile and go for interviews and all, right? So on other words, in simple words, I can tell this thing that if you go to Udemy or YouTube, I have so many different courses I created just to obviously earn money. So many courses I have, but this is the only course I created actually for the IT professionals, actually for you, where I want that you can go and get the job. That's why I have added whatever I have 15, 16 years of training experience. I have added all the best things from there, in terms of that you gain knowledge, whatever gray areas you have. Someone knows networking, don't know automation and cloud. Someone knows networking, they don't know firewalling technology, security areas. So that means that you can go enroll this course, gain the knowledge on those areas that you don't know. Or suppose if you have only 1 or 2 years of experience, then you can start this journey, complete the entire course within 5 to 6 months or maybe 3 months, and then add these things within your CV profile and get the job. So this is something like job oriented or career oriented training that is going to help you to get the job and right knowledge to showcase in your profile. All right, thanks for watching this video. In section 3, we have to learn about a storage area network, and we have to perform various type of lab tasks. So let's just start and let's go with the basics. So what you will find that after this video, you'll find 6 small videos related to a storage area network, where you will go and understand various SAN related terminologies. So what I have done, you can see that I'm going to explain that what are the storage area network types, the NIC card that is termed as a VHPAs, and different type of terminologies used inside SAN area network. Okay, so once we have the basic fundamental understanding, then we'll go and hit that syllabus one by one. So after that, I will go and cover. So let me go one step back. So you can see that section 3 syllabus or the agenda that we have to understand. So by completing all the 6 video, you will understand what is the floggy process, what is the ploggy process, etc. Means you will understand switch fabric initialization. We know that how the port channel is working. Likewise, we have in SAN, storage area network, we have fabric port channel. So you will understand the theorems, bundling the ports, etc. Later on, we'll go and do the lab related to port channel. So we'll understand more and more about that. Likewise, you will understand the FCID. CFS is nothing but again the fabric services. Inside that, there are so many different services. So at the moment you start working with the MDS switches, your fabric services are enabled. Correct? And due to these fabric services, things are exchanging inside the fabric. Okay, so once you understand the basic things related to a storage area network, zoning, floggy, FCIDs, all these initiator and target terms, means the terminologies. Then after that, we'll do, first of all, we'll do a small lab. And still my planning is to cover, first of all, my planning is to cover up to 3.1, because you can see that inside 3 you have 3.1a up to I. So we'll go and cover up to here. So we should have solid foundational knowledge. We should know that how the storage area network switches like MDS, multi-directory switches, look like and feel. It's again the Nexus operating system only, but there are so many different terminologies and terms going to be used. Correct? So first we'll go and complete our section 3.1, and after this video you have 6 videos related to SAN, and then I will show you the lab, a small lab. We'll do the introduction related to MDS, and then I will go and hit these terms. So what is device alias, what is NPV and NPIV, only these 2 terms. So after lab you have one video, and that video again related to the theory of device alias and NPIV, and then we'll do one related to lab related to device alias. So we should have good understanding about up to 3.1. Now once we understand up to 3.1 A to I, then we'll go and check the rest of the section. So let's first complete section from, going to be very interactive, and in the class you'll find that after every 4 to 5 slides I'll ask you few questions, and we'll work like this. So it is going
Okay.
to be interactive, and your participation will be very important. By the end of the class also I will ask you 3-4 questions. So let's start storage area network, and the class is divided like this: the storage area network, UCS manager. Why we are studying a storage area network, we'll see. It's important because not only we have the Ethernet traffic, that is the Ethernet, but we have the fabric traffic as well. So we'll understand that first of all the difference between the fabric channel. So we have 2 type of traffic nowadays: fabric channel, and we have Ethernet. In between also some of the devices they are supporting FCOE, fabric channel over Ethernet. So those protocols are also supported. Storage area network. What does it mean by storage area network? What you understand with this?
In a network that supports the data store, so we can access the data storage or whatever the hard drive on the server.
Yeah. So, uh, okay. So you are telling that, okay, uh, we can access to the storage. Storage may be different type of storage, maybe direct attach storage or network attach storage, or maybe JBOD, just bunch of disk, or maybe some sort of SAN network, for example NetApp or EMC storage. They have big arrays, like big boxes where they have the storage and all those things. Okay, great. So these are the disks. We'll discuss about all these things in our slide. But what is important, that you have server somewhere and you have a storage somewhere nowadays. Now these servers, they can have local disk, or they can have a storage from somewhere. They can boot from the disk, and they can boot from the storage as well, correct? We'll see
Yes.
what's the difference in between that. We'll see those things. Now, uh, important thing that we need to understand as a server engineer, that I may have a Linux operating system, I may have Mac, I may have Windows, etc. Now all these servers, they have different type of file and storage. So that means when Linux is going to be booted, they may request. So what is happening, we can understand like this. I have server and I have a storage. Inside the server and storage, I may have some network, any type of network. Obviously, we are assuming that we have FC, fabric channel type of network. So server and storage, in between I have some network. Now this server request that is going to the storage, the storage should also understand that this request is coming from Microsoft or Linux or Mac, and then it can provide that type of disk or that type of storage to these servers. Although these servers, they have the local storage as well, that also we'll see. Now what is happening in our case, that my servers, they are hosted over UCS, and then obviously you should have some network, because that is a standard practice. So you have some network, and then you have the storage. So I need to understand that how I can create the profile for all the blade servers and the operating system that is hosted over UCS. That is our main goal in this particular course. How the networking thing is happening, how their storage is working. For that, they may have different engineers. But here we need to understand that how we are going to do the stuffs over on the top of UCS. But if we have some basic knowledge that how this is working behind the scene, that will be good. So for that, I am going to take maybe 2 to 3 classes just to understand overall end-to-end mechanism. So here how the request will happen, how the storage will fulfill, in between what type of things I can get, and how these things are working. Okay, so one thing I want to point out here, always your servers are always initiator, and your storage is always target. So now we have the initiator to target relationship. Okay, and in between we have network, that is the storage area network. All right. Till this point, any doubt you have?
No, good.
Let's move on. So in a storage area network, you will find different type of devices, maybe MDS devices, maybe Nexus 5K. I think that is not in scope, but in between, this is in between. So I have server, I have a storage, in between these are the networking devices. All right, then let's move on. What type of storage we have? We have a storage arrays, we have SAN switches, we have host bus. So what are the components of the storage? So suppose if you have NetApp, storage, NetApp, that will become your storage array. Then in between you have the network, a storage network, that will be your SAN switches, but you have server also. Now these servers, they have called host bus adapter. This is important for us. We should understand host bus adapter or HBAs. So we have three component in the storage area network. One is the storage, one is the storage devices. It may be MDS, it may be Nexus 5K. Nowadays it may be ACI in between. And then you have the server. On the server, you have NIC card. That NIC card is HBA. HBA for FC, fabric channel.
Every.
Alright, we'll study more about HBA, we'll see. So when we are talking about the storage, what type of storage we have? So we may have just bunch of disk, means we have some disk inside the storage, or redundant array independent disk, RAID. Typically multi-level of redundancy, we have RAID 0, 1, 2, 3, 5, etc. SAN do not to be confused with direct attached storage or network attached storage. Direct attached storage is server locally having the physical disk. So I have laptop with some disk. Network attached storage is something like NFS or CIFS or SMB file share. These storage typically support three interface. Either it will support fabric channel, it can support ISCSI, this is for mid-range type of arrays, or it can support FCOE, fabric channel over Ethernet. So they are supporting these three interfaces. That means from the server perspective, I have HBA or virtual HBA, host bus adapter. Now these adapters can support this or it can support this. We'll see that we have converged network adapter. For SCSI also, I think we have SCSI adapters also. That also will be there. I don't know it will be there in your environment or not, but iSCSI adapters are also there. We'll see. We'll check in the Google. Okay. Then connect server to the storage FC to FC called. This thing we have just now discussed, that your server is nothing but initiator. All the time it will come, initiator and target, and your storage is nothing but target. And we have various protocol in our world, in the SAN world. We have protocol like FCIP, FCOE, ISCSI, and then in between we have different switches. So just before moving further, if I ask you some questions, give me the answer. What are the components of storage?
Oh, your voice is breaking.
Yep. What are the components of storage?
Component like direct storage and the network.
Yeah, only we have three components of a storage, or three components of a storage area network. What is this? First one is storage. Second one is the storage network devices, and third one is the HBA.
HB.
Okay, what is the use of HBA?
It's like a fabric channel just provide link
Is the
into the
interface? Is the interface? Yeah. It's a NIC card. NIC card for fabric channel. NIC card for storage. Okay, and the server, what we are telling the server is termed as a
target.
Initiator, and a storage is
Server
termed
is
as a
and the storage is
target. Great. Okay, these points, that's very basic things. Let's move on. So next what we'll do, next we'll go and check the NIC card. NIC card for the storage, they are termed as a host bus adapter, and here you can see that we have the HBAs. We are going to see this, the speed of HBA also. They can be 1, 2, 4, 8, 16 Gbps. We have ISCSI HBAs as well. So we have NIC card for straight for SAN network. We have NIC card for ISCSI as well. That is 1 to 10 gigabytes LAN plus hardware offload HSC. So let's see some of the NIC cards related to storage, and then we'll move. So Cisco HBA and ISCSI should be ISCSI. This is not Cisco site. We'll go to the Cisco. Oh, yeah, this is. I'll ping you this link just for your reference. All right. So now here you can see this is the logical diagram that I have server. Server has 2 HBA. Let me draw here. So here you can see that server has HBA1, HBA2, and it can have VNIC. So this is for Ethernet traffic, and this is for fabric traffic, fabric channel. Apart from that, server can have FCOE and ISCSI traffic. Now let us see the NIC card related to this. These are again the protocols. We'll discuss more on this. If I'll get the NIC card, I want the NIC card from the Cisco site. So HBAs are typically defined by interconnect technology, port speed, etc. The HBA sometimes called HBA card. The HBA card often plugs into the PCI Express slot in the server. Other HBA form factors include mezzanine cards for the blade server. So actually for blade server, that in UCS, whatever cards that we are going to study, that is mezzanine card. And let me open the Cisco mezzanine card comparison. It's coming up. So here you can see we have the WIC cards. We are going to discuss more on this upcoming section, but these are the HBAs. And if I scroll it down, little bit down, you can see the form factor is mezzanine, or it may be PCI connector. They have various features inbuilt inside that. For VXLAN also they can provide, and they are used inside the UCS blade servers. Later we'll discuss more about the UCS, but these are the WIC cards, and all these WIC cards, they have some features inside that. Okay. Now if you see the overall diagram, how it look like, where is the server, where is the storage. So here you can see that if I remove this particular section, you can see where is the UCS. Here I have my UCS. Inside that I have blade servers. I have input output module that is connected with FIA and FIB. Now very interesting, here you can see that your FI, fabric interconnect, has some interfaces going to multi-director switch. This is switch for fabric channel. So I have some SAN related traffic. Some interfaces they are going to LAN, means some are Ethernet traffic, some are fabric traffic. But inside your FI you have both the option, correct? Going like this, going like this. So how it is going, so you can see that overall traffic flow, it will go through the MDS and then it will go to the storage. So here I have a storage. Here I have the initiator and here I have the target. But in between, there are so many things happening. So in between all these blade servers, they have HBA. And in between a storage and the target, they created some rule. That rule will tell, okay, Microsoft will talk to certain LUN, logical unit number. Say Linux will talk with some LUN, logical unit numbers. It's like mapping of the storage to the mapping of the server to the storage. It will happen. Some rule, some ACL access control list entries, some zoning. Generally, we are telling us zoning rules will be there. That's it. So between the server and the storage, what rule we have? We have zoning rule that will tell that how server will map to the storage. This is the overall picture. Now, maybe in your organization, here you will not find this type of infra, but it may be ACI or it may be NSX overlay.
Yeah.
I think it is NSX overlay.
NS.
So instead of these Nexus switches and all, you will find NSX. But in that case also, you should have zoning and you should have your servers mapped. So server rules mapped to the storage. It should be there in between that. All
It's
right.
the same thing with the VLAN and that all is the same, like synonyms
Yeah,
or
in
VLAN is
yeah,
totally
VLAN
different.
also. So here we have a term called vSAN, virtual SAN, and virtual SAN should map to the virtual LAN.
Virtual LAN.
Yeah, so here we have actually zone A and zone B. So vSAN may be 100 and vSAN 200. Only two fabric you will find in the production, or maybe three. So side A, FIA will map to vSAN and the VLAN. Side B will map to the vSAN and the VLAN. It's like that. So that's why you have redundancy. If any of the side will go down, still your servers will boot up because you have FIA and FIB for redundancy. Alright, so let's move on. Now, this is a logical diagram we can see. We should understand that what is the meaning of different type of port or what is the port rule. So here I have a storage, here I have a storage. You can see here I have host and a storage. I have host and a storage.
Sure.
So obviously your host, you can see this is small icon. This is the NIC. This is the NIC, a small green color icon. So obviously this NIC is nothing but HBA, and HBA is connecting towards the storage. Whenever we have this type of arrangement, the host side port always term as a N port, node port. N stands for node. And the other side, you can see this side is also node port, this side is also node port. L is something like loop, node loop. L stands for loop, but you can leave that. We are concentrating only two things. One is N for node and then F for fabric. So we have node port we have fabric port, and then in between switch is the extension port, some E port, some extension or expansion port, something like that. That we can leave it at the moment, but you can see that node port is there. Maybe this term you will get related to the server, related to the storage, and then you have the F port that is towards the switch.
Switch.
So if I draw this diagram, like a simple diagram, if I try to draw, so suppose I have one fabric switch, I have my storage, fabric switch, I have my server. So this portion will be node. This interface will be fabric. This interface will be fabric. This interface will be node.
Nodes.
Okay, and in between, if you have switch to switch, then those are E, expansion ports. Okay, so these are the FCS standard ports, port types. Generally, we'll think about node port and fabric port. All right, let's move on. Let's see other stuffs. What is fabric channel? Can you tell me what is fabric channel?
Mm, Like definition is like a connection in between whatever the server and that provides the any kind of connection between the server, the storage, and the network.
Okay, fabric channel is a term used for storage area network, correct?
Uh-huh.
All right, we'll discuss about this thing in the next slide. So here you can see the fabric channel. It's a protocol stack primarily used for iSCSI or SCSI command over SAN. For SAN, we have the protocol. So for LAN, say for example, we are using TCP IP protocol stack. Correct? We have the OSI model or TCP IP model. What is that?
Uh-huh.
Physical layer and the data layer, and finally we have application layers. Like that, we
Application.
have like
Uh-huh.
that. In SAN, we have fiber channel. This fiber channel or the fabric channel is the protocol stack related to, if you compare with the LAN, for SAN we have the fiber channel or fabric channel protocol stack. It is defined under these RFC. If you go and check these RFC, you'll find more on that. Let me show you that how it look likes. So it look like this. Now the OSI stack, you can see the physical data link, transport, session, presentation, etc. The FC channel, you can see FCOE channel, the physical and the data link layer. The network layer is, again, you can see the different standards are there. So I have FC0, FC1, FC2, FC3, FC4, etc. So FC4 is nothing but protocol map, and then this diagram you can refer. So it is not showing any network layer. It has physical layer FC0, FC1. This is FCFS, FCPI. Then is a data link layer, that is FCFS, DI, etc. That means that in these layers we are going to use HBA, host bus adapter, because where we are using the NIC card, generally in the data link layer we have the NIC card where we can give the IP address as well. Here I don't have any IP address type of thing, but we'll see what is the logical representation of IP address in the fabric channel. Then you have upper layer protocol, FC2, FC3, FC4. So this is the fiber channel protocol. It's like simple than OSI model, because here everything FC0 1. So if I remember, FC
Yeah.
start with 0 and it will end with 4. 0, 1, 2, 3, 2, 3, 4, like that. So it's a compressed model, you can see, where I have 0 to 4. That means I have only 5 layer The physical and data link layer as it is. Then we have framing, service, and protocol. And here one note we have that FCP, fiber channel protocol, is analogous to TCP. Okay, this is actually very important, this FCP and TCP thing. Fiber channel protocol. So what protocol we are using in fiber channel? That is FCP, fiber channel protocol. All right, so far any doubt? So now my fiber channel topologies, they are supporting, it's actually very important slide. It's very important. Which type of topology the fiber channel is supporting? It supports three type of topology. One is point to point. So what is point to point? That means your server is there. I'll write SR for server, and then you have a storage, ST for storage. This is point to point connection. So here you can see the initiator, that is the server, target, that is the storage, directly connected to the loop or arbitrated loop. It's like point to point connection. Logic A logical ring topology similar to ring implies contention required to the ring. I'll leave it, but point to point, direct connection, straightforward. Then switched fabric, logical equivalent to switch LAN. Switch manage the fabric, allowing any to any communication without and other. So other is that you have your server connected with network, and then you have the storage. Okay. What is the third type? It should be like your server directly connected to disk.
Okay. Local area or like a storage?
Direct storage.
Okay.
Okay. So we have these three types. And what type that we are going to get is this. You should have this.
Network.
Yeah. In between you should have network. All right. So we have some ports. What was that ports? Let us see. And what we can focus here in the port types. So I'll draw one diagram. You tell me what is what. This is my server. This is my switch. Again I have switch. And then I have my storage. ST for storage. So here what port?
Node.
Yeah.
N. E.
Here.
Oh, sorry. F. F. F.
F. Yeah. Here.
That's again.
Should be E, expand. Switch to switch
E.
expansion.
Yeah.
And
E
here.
expansion. That's the node.
Here fabric. Yeah. It's like that. Great. Let's move on.
E stand for interconnect, right?
It's like expansion.
Expansion.
Yeah, expansion, like trunk type of thing. In switch we have trunk, VLAN trunk, like that.
Oh.
All right. Now we have the addressing schema, and this is actually very important. Whenever we'll create the service profile, we will get these things. So what about the addressing? In local area network, we know that we have MAC address and we have IP address. What about a storage area network? In a storage area network, what is the MAC address? What is the IP address? So MAC address, what is the significance of MAC address? It's a burnt in address, correct? Burnt in address. It is burnt inside this chip inside the ASIC. Is the physical address, correct? This MAC address is physical address. And the IP address is the logical address. Likewise, we'll see in SAN what is the MAC address and what is the IP address. So FC addressing is analogous to the IP over Ethernet. IP addresses are logical, manually assigned to the MAC addresses, burnt in address. FC worldwide node name. This is the 8-byte address. Then we have FC ID. Remember, here we have two addresses. One is FC worldwide node name. So FC ww node name. And then we have FCID. FCID. This is 8 byte and this is 3 byte. Okay. Now this FCID is analogous to MAC address, and this FC worldwide name or WWN. You can remove this thing just for your memorization.
Yeah.
WWN or WW node
Got
name. This is analogous to MAC address, and this FCID is analogous to IP address.
it.
This is 3 byte, this is 8 byte. Alright, how it is built, let's see. So WWN is FC, fabric channel 8 byte physical address. WWN is subdivided further into worldwide node name or node worldwide name, switch server disk physical address, and they are divided into worldwide port name. So what it is telling that if you have one server, so this server having only one physical address, correct? And this server has say HBA, host bus adapter. So this particular WW node name is identifying the physical address of the HBA. But suppose inside this HBA you have two interface, means suppose if you have two port, that will term as a WW port name. So WW port name 1, WW port name 2. So here you can see that is HB and the arrays have more than port. It is not a data plane switching. So we have port name also. What does it mean? The switch VHB is worldwide node name, but the interfaces. So one interface can go to fabric A, one interface can go to fabric B. These are WW port name. WW port name. Okay, and how it is important. So if you see now your UCS blade, suppose I have only one server. In one server I have one HBA. So what I will do, that one port I will map toward FIA and one port I will map towards FIB. So the HBA physical address is WW node name, but the port name will be, so here I have one port, different port, and here I have different port. Now what is the significance of different port? Now it can map to storage A and it can map to storage B. In between that, if you create the zoning rule, so zoning will tell, okay, WWPN1 will map to storage A and WWPN, say for example 2 will map to storage B. That's the importance. So if any of the site is down, is still your server can get the storage from one side.
Okay. Okay. So, okay, just one question. So, we have like two different storage area, or we
Yeah, always
just
you
like
have two different.
considering
You have one storage area separated into two logic.
two?
So that's why you have vSAN. Otherwise,
Mhm.
everyone should use vSAN 0. You'll find you have vSAN 100, 200. This will map to vSAN 100. So one side is completely one logic. This will map to vSAN 200. But by the end of day, you have redundant path towards the server. Because you have two
Oh,
interface, because you have two storage, they are mapping independently.
mhm. Okay.
All right. So then we have the FC identifier. This is something like IP address. It's a logical address in the fabric channel. FC ID is divided into three fields: domain ID, area ID, port ID, and all these things having the significance. So area ID is a group of ports in which switch area is there. Port ID, end station connected to switch get the port. Domain ID, which domain it belongs to. We don't need to go deep inside what is in the domain ID, area ID, port ID. You can just think you have domain ID, you have area ID, you have the port. So port is significant locally. You can think like this: area, inside area you may have port, and then inside domain you may have area. It will be like this.
Okay.
All right. So at the moment, what we can do here, that we have MAC address things. MAC address things are www node name
WWN
and www port name.
port.
Then we have IP type of things, that is FCID. He has
Same.
gap at the moment. Domain area port. All right. And for example, why I need IP? For routing.
To connect with
For routing,
yeah,
correct? So the traffic will use these IP addresses to build the routing table. So in this case, they will build the FC table, because in between I have network. So in between,
yeah,
say for example, I have UCS here connected with A and B. Then I have network. In between, I have multiple switch, and then I have a storage. So how the traffic will go from one place to other place and then reach to a storage? For that, we need the logical IPs to build
yeah.
the logical
Path.
fabric routing. They will do here. So once you connect various type of switches, they will first of all select who is the principal switch. Only thing then required is that we have to create the zoning. Zone means the server and the storage, they have to map. So how they are mapping, and if you want to see the mapping database, you can see inside the we have to discuss that thing. You can see inside the Floggy database, and then we have the overall what I can say, the DNS type of, or the mapping type of a structure, that is nothing but FCNS. We are going to discuss these things, Floggy and FCNS, after 2-3 minutes. All right, so now you can see here that yeah, they are running one protocol, fabric shortest path algorithm. It's like OSPF type of algorithm, and once you are running the any type of routing type of protocol, so whenever you are running the routing type of protocol, say for example FSPF in this case, what will happen, that what will happen here. See, remember, I'll tell you one nice thing about the routing protocols. And in data centers, why we have routing protocol. Have you heard about data center technology, say for example, fabric path?
Not really. I heard the name, but not indeed.
Okay. Okay, so I will give you a little brief about the generation of the, if I give one, if I get one blank slide. Yeah. So see what is happening, if you see the generation of data center. So first of all, there was one protocol called STP, spanning tree protocol was there. We used to use Catalyst 6500 switches, along with we used to build the uh, core distribution and access layer type of structure. Then next generation Nexus 7K come into the picture. Once Nexus 7K come into the picture, then Cisco has introduced VPC. And along with VPC, they are telling that okay, because STP has issue that 50% of link, maybe you know the spanning tree first protocol, 50%
Yeah, yeah,
link
yeah.
will be 50% link will be unutilized. You may know this thing, correct? So that's why
Mm-hmm.
they thought of that why we are not using routing instead of routing instead of what we have something say L2 STP protocol. But if you study routing, maybe you know that routing is something related to IP addresses. So a routing table, they are forming the IP address table, etc. Then Cisco introduced one concept called say fabric path. And inside fabric path, what they have done that they have introduced layer 2 routing. Layer 2 routing means MAC based routing. And underlying protocol that they have used was ISIS. Alright, so if you have any question, you can ask, no problem. Yeah, even you can type also. So then MAC based routing, Cisco has introduced inside the fabric path. Now, if you use MAC based routing, then what will happen that if you have multiple link, because now you are using what? Routing. So if you use routing, then there is no concept of blocking the ports. That means 100% ports you will utilize. Okay, and then they started the concept of leaf and spine. So you have leaf and spine, etc., where 100% of link you are utilizing for traffic. Now, if we use both the link in routing, they are termed as, so suppose if traffic is coming, it has option, it can go via this, it can go via this, or both. And generally they will choose both the link to reach to the destination. So that's why it is something like multi-destination. So they are forming multi-destination tree in this case. Now what will happen here that if you are using this type of methodology, that means you are doing the load balancing, correct? Now suppose this link and this link both have the same cost, suppose 1 and 1. So that means I am using equal cost load balancing. This equal cost load balancing is nothing but ECMP, equal cost multipath, actually equal cost load balancing method. It is used inside equal cost multipath. Why? Because you have two equal cost path. His cost is also 1, his cost is also 1. That is the metric value of the routing protocol is the same. So that's why it can go via this direction, it can go via, means now you have active link in short. Instead of STP where I have the active and block link, I have active link. Now the same strategy this SAN area network is doing. So when we are talking about SAN area network, so suppose I have switch 1, switch 2 and switch 3, and then for example you have the server, and suppose you have one more switch, switch 4, and then maybe you have the storage. So they can send the traffic both the link. Maybe you have created zone A and zone B, that is different thing. But since they are using SPF algorithm, shortest path first algorithm with fabric. So fabric shortest path algorithm, by default it will be on. At the moment you do the configuration, it will be on. So they are doing ECMP, equal cost multipathing. So there is no concept that any of the fabric link will be blocked. Got it? Any doubt in this?
No, I think good.
All right. So now here you can see that ECMP is supported for equal SPT, shortest path tree branches. Unequal cost load balances is not supported. So if you are going somewhere, if cost is 3, and then you are going somewhere if cost is 2, it is not supported. It should be 3 3, so it can do equal cost multi pathing. FSPF runs automatically as a fabric service, no configuration required. Can customize if you want, you can tune some sort of like metric value, attributes, the password, authentication, etc. Otherwise, no one is changing anything. It is running by default. FC does not use flooding to build topology like Ethernet. You know, Ethernet, when we study Ethernet, so what is happening that any frame is coming to the switch because he don't know the destination. So he used to flood. That means except whatever interface he got the frame, except that frame, he will flood, he will send that broadcast message, you can say, or generally we are telling flood. So he can flood all the interfaces and he can send the packet that, okay, I don't know the destination. Then they are using flood and learn method. But here we don't have flood and learn method. We are using the routing protocol. Now, how they are building the routing protocol, what is the process behind that, we'll see. So here you can see the question that I ask you, that Ethernet connections, Ethernet network are connectionless. Traffic in the data plane results in topology learning in the control plane. Fabric channel network are connection oriented. That's the key. That means this will provide you lossless type of strategy. Why lossless? All end station must register with the control plane of the fabric before sending any traffic. Because say this is my server and say this is my storage. From server to storage, it's not like they start sending or receiving the traffic. First of all, they are going through various process. One process is fabric login. So suppose in between, if you have one switch, he is doing the floggy process with the switch. Switch is doing the floggy process with the FC. So what is there in the floggy process? In the floggy process, they used to learn their port wide node name or WW port name. So worldwide port name or port wide node name, whatever we can say. So they are learning that which interface the request is coming. He will also learn what is the source, what is the destination. But remember, this floggy is something like local. Then they have the port login. So once they do the floggy, that initial handshake, then they will do the ploggy. That is the port. Now they can learn the uh, source and destination. You can say that MAC learning type of thing. They will do the layer 2 learning with fabric login with port login. Once they do the floggy and the ploggy, then they will go to process login. Then they will send the actual traffic. So here you can see that I am doing floggy, he is doing floggy, I am doing ploggy, he is doing ploggy. Then I am sending the query that, yeah, actually what is happening, that is again interesting in the fabric world, that they are using something called credit based transfer. What is credit based transfer? That this server will ask this storage, or you can think like in reverse direction. This storage will ask this server that how many packets, I can't tell packet here because packet is associated with the uh, LAN or the Ethernet world. So I can tell that, okay, how much data you need, for example. So he will tell that how much credit you want. It's something like, say, for example, bank accounts, or you have, say, for example, 10 lockers. So then you can open 10 lockers, something like that. So he is asking actually that how much you want. And then he is telling, okay, I need 10. Then they are start sending and receiving 10 bytes. It's something like that. That's why it's lossless, because they are doing the credit based uh, data transfer. All right. And then once they do the ploggy and floggy, then they will start sending and receiving the traffic. We have fabric login. Okay, we have study about this. So what is happening in the floggy? Switch learns the WW node name and port name. Switch assign the FC ID to the node. So layer 2 to layer 3 resolution, you can think. Floggy, end-to-end login between the node port. Initiator means server tells target it wants to talk. Used for applications such as end-to-end flow control. So now once they do, so he will do the floggy, he will do the floggy. Now they can do the ploggy. But in between, here they have done the ploggy, here they have done the ploggy. Then we have the upper layer protocol. That is means once they do the floggy and the ploggy, they will start transferring the credits or the data packets. All right.
So
Yeah.
we have to set up all three, right? First of all, we have to set up the floggy, then we have to set up the port logging, then we go for the process logging, right?
Yes, correct. And what we are checking in the switch, like in MDS switch, we used to check show floggy database. In this output, you will see what is the source and the destination. If source will not map with the destination, then the exchange will not happen.
Okay, got it.
Alright, so if, yeah. So we have a study about the FCID or FCNS, Fabric Channel Name Server. What is that FCNS? FCNS is analogs to ARP cache used to resolve the WWN to the FCID logical address. Like Principal Switch and FSPF, FCNS is a distributed fabric service that do not require any configuration. So at the moment we'll think that FCNS is nothing but L2 to L3 resolution that's happening in the ARP. ARP is also doing MAC to IP type of resolution, correct? FCNS is also like that. The question here that why in the first place I need FCNS type of thing, because now we are doing the SAN routing, and in our example the SAN routing they need something L3 type of identifier to do the mapping between the initiator and the target. So that's why we need the FCNS to WW port name or WW node name resolution. All right, so till this point you have anything you want to ask?
No,
All right, thank you. So let's move further and learn some more terminology inside the storage. So by default, initiator joining, it's very simple. If you know ACL, where you have source and destination and some rules, it's like that. Joining means you have initiator, you have target with some rules. It's like access list. By default, all initiator learn about the target during the login process. FCNS maintain the mapping of the uh, node name and the or port name and the FCID. Server mounting the wrong volume can corrupt data. Yes. So who will monitor that? How the server will not get a wrong volume? Maybe that Linux will get some Windows OS or something. How? It will not go and check the wrong operating system. So for that we have the zoning. Zoning prevents this by limiting which resource as initiator can use. Zoning is analogous to ACL in Ethernet. Associate WW node name, FCID, aliases, etc. to control who can talk to who. Like FCNS, zoning is the distributed fabric service. It's like distributed means across the fabric, throughout the SAN. So joining is also like it is throughout this, and because the rule is throughout the storage area network. FCNS is also, it is also like a entry L2 to L3 resolution. But joining is something that it's a ACL type of thing for the initiator and the server, or initiator and the target, sorry. Now the last terminology we have is the virtual SAN, and vSAN solve the isolation problem to similar LAN, etc., etc. Why we need the vSAN? I'll read this slide. Why we read vSAN? You think like this. Say you have a storage, correct? Now you may have a multiple path from server, but for example, if all these domain, everything will be part of only. So for example, vSAN 10. That means if vSAN 10 will go down, your initiator will not reach to the target. So that's why what we are doing, that we are creating. So you have your storage and you have your server. So we are creating multiple virtual SAN. So I can have SAN 1, or for example SAN 10, and I can have SAN 20, and then they can reach. So now I have fabric A and fabric B, just for the sake of redundancy. If anything will happen with fabric A, is still my HBAs, is still my worldwide port names, because I have two worldwide port names, one map with the zone A, one map with the zone B. They will not go. Still I have one path to reach to the storage. So that's the reason we are using vSAN solve this isolation problem, similar to how VLAN segment broadcast domains isolates the management of the fabric of the domain. So whatever fabric failure of the fabric domain, the network separates the, now for all the vSAN, so vSAN 10 and vSAN 20, they have separate uh, floggy FCNS zoning. 20 also has separate floggy FCNS and zoning aliases as per vSAN. With vSAN's E port become trunk E expansion, similar to the Ethernet trunk. All right, you can ask if you have any doubt in this.
vSAN is good. So basically, I see some of the videos. So basically, we created the vSAN like 1 to 10, and we just connect all the 10 with the storage area and the server be in between. So if something is happen in 1 or 2, we have like 8 or something is running, right?
Yeah, actually, you in production, in real production, you'll find only two vSAN. vSAN 10, 20 or
Oh,
100, 200. We are not creating
mhm.
much vSANs. In most of the network, you'll find only two, A and B.
Okay.
And why we
Mhm.
have two? Because what you will see, that since we have two, because in UCS I have FIA and FIB. So FIA will map with vSAN 10 and B will map with, say for example, vSAN 20. So you'll find only two, but you can create multiples. Most of
Okay,
the time you will
got it.
find only two.
Mhm.
And then like in Ethernet, in SAN also we can bundle the FC ports. So suppose if we have 10 gig one port, uh, you can bundle up to 4 ports, so it will become 40 gig overall throughput. So like in Ethernet world, we can bundle, we can create Ether channel. In SAN also we can do SAN port channeling, and the protocol is 8023AD. So in the UCS manager itself, you have various tabs. One tab is SAN. If you go inside that, you will find various options. One option you will find to do the bundle, to create the port channel. So for example, I have my diagram, say for example, my FIA having two connection, having two FC connection, fabric channel port, connected with, say for example, MDS or Nexus 5K. So in that case, you can bundle them in a SAN port channel. If you bundle them, as per the bundle, they will use the hash method to do the load balancing between across the link. So they will use that and they can load balance. So suppose this is 10 gig, 10 gig, overall you have 40 gig throughput to the uplink. Let us understand device aliases. So what is happening? We know that while creating the zoning, we need the initiator and target, but while creating the zoning, that is dependent upon port worldwide name. So you need port worldwide name, and then you have to give the initiator and target to create the zone. Now the problem with port worldwide name is that they are in hex character, correct? They are not a user-friendly name nomenclature. We need some sort of technique where we can get user-friendly type of name, and device aliases are solving that issue. So what we can do here, and you can see here in the command line, that you can go and you can convert your port worldwide name as a user friendly name or as a friendly name. So that means that whenever the database will get replicated, that fabric information will get replicated, they will get replicated with respect to my friendly name, whatever I have. So we are just creating some sort of name aliases that your port worldwide name will be known with friendly name, and across the fabric it is true. Even in future also, if you are doing the troubleshooting with that Floggy database information or with that FCNS information, will come to know that this PWWN belongs to where in a fabric, correct? So that's the usability we have. Now, what I will do that, let me go and quickly show you how we can configure this. To do the configuration is easy and straightforward. We have certain steps to follow, some 4 steps that we can follow and we can create it, correct? Now, once we go and create it, obviously you can show these, see this configuration inside the FCNS database or Floggy databases, etc. So let's go to the switch and go to the configuration mode. And before going there, I should go and check the Floggy database. And now what we can do that you can go to the device aliases database. Once you are inside that database, then you can go and give the device alias name, give the friendly name, say storage area, whatever name I'm giving one. And then we should go and give the port worldwide name, and this big string we can go and assign, correct? Now another device is present with same, so it is telling that some configuration is already there and uh, already present with same PWWN, and if we can go and use this command to reject it. So if you have some old configuration, pending configuration, you can go and check that, correct? So rejection command is also there that we can go and use it. I can see here that storage area 1, this is our storage area 1 name. Okay, so what we can do the commit. Actually there is option that we can once we create it, we can go and do the commit, or even we can do no as well, correct? So let me show you this if we have created any. Yeah, so you can see that the old configuration was there, but again let me show you the configuration here as well. Show Floggy database. I'll create one more entry here. So now you can see that one of the port worldwide name is known as a storage underscore A1. Likewise, I'll go and create one more. So we'll go to the device alias database, and this time we'll go and give the name. So friendly name, I'll copy this, I'll make this A2, correct? And then you have to give PWWN, and then you can go and use this information. Oops, let me copy and paste, enter. And now we can go and do the device alias commit, and then we can go and check sure and include device, and here you can see. So this is the configuration that we have for these port worldwide name. And now if you go and check the Floggy database, so here you can see that it is getting replicated as A1, A2. If you go and check FCNS database, so here also you should see A1 and A2. That's the importance. Simply, it's a user-friendly name, and it's easy to store in terms of that visibility is there. We know that exactly what nomenclature we have given. So it's easy to actually identify, and it's easy to troubleshoot as well in future if we have any such problem related to Fabric while we are doing the troubleshooting. Let us understand NPV and NPIV. Now, NPV is very important while we are talking about the scaling of the fabric. We know that whenever switch registered inside the fabric, they are getting the domain ID. Now, domain ID is 8-bit or 1 byte field inside FCID. Now, if we do the mathematical calculation, you'll find that 8-bit means 255 And again, if there are some reserve IDs, that means the number will still go down. So that means that if we have big infrastructure, in that case, the fabric will not scale properly until unless we'll go and do some technique. And that technique is nothing but NPV, node port virtualization. Now, how this technique is working, let me try to draw here. So suppose if we have 5K switch, and suppose if you have servers, or maybe if you have switches. Now all these servers or switches, they will go and they will try to become part of fabric. So they will do the floggy, and then they will get the domain ID, correct? Now, again, in terms of scaling, it's not good. Suppose if you have upstream switch MDS, it is connected with MDS, and again, you may have somewhere a storage, correct? Now, the technique, what this technique is telling is that you can go and enable NPV. Actually, the feature is NPIV. We have to go enable that. We'll do this in the upcoming video when we perform the DCNM related lab. At this point, so you can go and make this 5K switch so that they will work as a NPV, node port virtualization, and the MDS switch that you have, they will work as an NPV core switch, correct? So that means the port role here to this Nexus 5K will be node proxy. And obviously here you have the fabric because this is the MDS. So this is working as a node proxy, and it is going to do the proxy for all the requested that is coming below the Nexus 5K. So in that case, all those below requests, they will simply, they are doing the proxy. That means they are bypassing, and then they are reaching, means that request is reaching to the MGS. That's the whole concept behind the NPV. Now, next important concept that you have related to NPIV. So NPIV, basically what it is doing, that this is the key here, that it will go and allow multiple floggy and FCID assignments. Okay. And one of the nice use case we have related to VMware, I will show you in the next slide. But here, this MDS switch, we can go and enable NPIV features. So multiple floggy and multiple FCID assignment can be done. Now, let me show you the diagram related to example related to VMware host, that is assigning the separate port worldwide node name FCIDs to the VMware guest. So now here you can see in the diagram that you have your VM host, correct? You have your NPIV switch, that's your MDS switch, correct? Now this VHBS, which is having the multiple session. So one of the host, it is giving LAN1, other host, it is providing LAN2. Part of same virtualization area, you can see that it is doing multiple FCIDs, or it is doing multiple floggy, and the hosts, they are getting the individual LUNs. So initiator and target, but inside same box, they are creating the virtual environment. Correct. So the VHBA talks to the NPIV enable switch and runs floggy process twice. Multiple times it can do the floggy and FCID assignment. So two FCIDs, so that host 1 can be in the zone with LAN1 and host 2 can be in the zone LAN2. Okay, so this is the importance that we have related to NPV and NPIV. These are the virtualization techniques that we are using inside the fabric, correct? All right, so let's stop here. So this is our lab setup. Here you can see that we have 4 MDS switches here. So edge 1 and core 1, like that we have edge 2 and core 2, and they have the connectivity. We can see here the connectivity. So in between these MDS switches, oops, let me go to that lab. So in between these MDS switches, you can see that we have interfaces 3 to 6, interfaces 3 to 6. Then the core is connected with the storage, and you can see the interface 1/1 to 2. And then these edge MDS, they are connected with the compute. So this is our topology diagram. What we are going to do, we are going to perform one very basic lab here. So I'll go and do the no shut to the interfaces inside edge 1. Actually, all the devices that we have, edge 1 up to core 1, edge 2, and core 2. So we'll go and do the no shut to these interfaces. When we unshut the port, then the floggy process will start. Correct? So the initiators that we have, they will go and check the targets, and then they do some sort of control packet exchange or control frame exchange. Correct? Because in the fabric, once you go and enable all the ports, the CFS will start running in between, and all the services will get enabled in the default mode. Again, later on we can go and create zonings, and we can create certain rules that who will talk to who. So which particular initiator will go and talk to which particular target, etc. So those rules we can create later on. But if you go and run this service, then the the fabric routing protocol, that's the OSPF. So FCSP protocol will start, and they will build the routing table. And we have discussed all this theory earlier. So that the initiator will go and get the target, and we can check this inside the floggy process first. Second thing, that again we can go and check the entire database as well. So we know that how we can go and check the database. To check the database, we can go and check the FCNS services. Correct. So first of all, I'll do one thing. We can go and check the FC1/1 up to 6. I'll do no shut, and then we can go and check the interface brief. So here you can see that the interfaces. We know that switch to switch interface is TE, correct? These are the expansion ports that we have, trunk expansion. And then the port that is going towards the compute towards the server, those are F, correct? So that's great. And now what we can do here, we can go and check show floggy database. So with this, you can see that you can clearly see the initiator and the target is that you have the floggy with your port name and node name, and you have the FC ID as well. These are the logical addresses, and then you have the physical addresses as well. Great. Likewise, you can go and check so FCNS database as well. So let me quickly show that. So FCNS database, this is very much similar like ARP cache, where you can see that entire fabric, where is your initiator, who is your initiator, and who is your target. Correct. So knowing these facts, we will go and continue our lab. We'll go and add more and more lab items, and I will show you in the upcoming sections that how we can go and utilize this lab more and more. So what we can do here now, we can go and stop, and in the next upcoming section, we'll continue our basic labs. We are going to perform lab here, and in this basic lab, with help of DCNM, we'll go and discover first of all the MDS switches. So first thing that I want to do here is to do the discovery. And once we do the discovery with help of DCNM, DCNM is just a management tool for data center network. It's an easy tool. Once I log in, I'll show you some of the tabs as well. It's easy to use. And if you go and add DCNM inside your CV, because nowadays I can see that organizations, they are looking for engineers who at least know how DCNM work, what's the basic functionality and all. So you can understand that as well in this particular section. Great. So first of all, we'll do the discovery, because whatever management tool nowadays we have, they are doing the discovery. Okay. So discovery means we'll go and add the MDS switches that we have inside the DCNM tool. Once we go and add that, then we'll go and check the topology. Okay. And once we check the topology, then we can go and use some sort of SAN analytics as well. We'll understand about this SAN analytic, how we can go and collect various type of SAN information inside DCNM. But remember, in last section, we have discussed about NPV and NPIV, node port virtualization and node port ID virtualization. So in this lab, first of all, I will go and enable the NPIV feature as well in all the switches. Okay, so let's go to the lab. Let me go and open the switches. Yep. So we have all the switches here. I can go to all the switches one by one. And what we need to do here, we can go and enable the feature NPIV. So let me show you that NPIV. And the same feature, I will go and enable to all the switches. So we can go and enable feature NPIV. We can go and enable the feature NPIV. And once we enable the feature, obviously we can go and verify as well. So what you can do, you can go and check show feature enable, and just to see that a feature is there or not. So you can see that this feature got enabled. That's the first thing. Second thing, let's go to the DCNM and do a rest of the lab task. So here you can see, let me go to the dashboard. I can show you the dashboard first, how this look like. So here you have the DCNM dashboard, and this DCNM dashboard that we have, you can see the dashboard summary. At the moment, nothing is added, so that's why it is showing blank. Nothing is there. But it's nice data center management dashboard where you can go and add inside the inventory. You can see switches. I can go and do the discovery for the LAN, SAN, storage, virtual machine managers are also there. Correct. Then we can go and we have this monitoring option. We can go and monitor the switches. You can see the switch CPU, memory, temperature, etc. We can go and monitor the SAN, LAN. We can generate the reports, alarms as well. Then we can configure as well. That's the thing. That's very important thing. Interesting thing we have. We can go and do the configuration related to various data center tasks. Okay, few of the configuration we are going to do in this lab in the upcoming section, but we can go and do the configuration not only related to SAN but LAN also. Like you can do the VXLAN configuration. In SAN you can create the vSANs, joining, port channels, good amount of thing we can do, correct? And even we have the SAN insights as well. Now in this we are going to touch few. So first of all, let's do the discovery. Because once you go and do the discovery, so let me go and click SAN switches. You know that we have 4 different switch that we can do the discovery for. So I can go here and we should give the IP. So I have the IP with me, and this is one of the IP. Yeah, SNMP version 3, username and the password that is required. Then use SNMP, that's okay. Enable NPV discovery in all the fabric. I want to add this. I can see that discovery is in progress. Likewise, I will go and add rest of the devices as well. So we have Edge 1, Edge 2, Core 1 and Core 2 that we can go and add, although it is taking a little bit of time here. While it is moving, I can go and give the other IP and the username and the password. Add this. Then we'll go and add remaining 2 core as well. So these are the edge, and we have the core as well. One is 254.123, and the password. And then finally, oops, fabric already exists. So this seems to be already there. Great. Let's see. 198.19254.123. Okay, this auto discovered seems no problem. Then let's see if I can go and add 4 here. Admin 45, add this. Okay, great. So what I can do here, I will wait till the discovery completed. And once this will be done, then next we can go and check the topology. So if you go to the topology, and now it is loading, let him load. And then we can check whatever we have discovered, it will come here. So now you can see that core 1, edge 1, edge 2, core 2, like all the devices got discovered, correct? Great. Now, once these devices that get discovered, so what we can do next? Obviously, we can do the configuration and all, and we will do the configuration in the upcoming section. But one nice thing that we can do here is that we can go to the administration, and you have this option called SAN collections. And if you check mark, you can see if I go and check mark this, we can go and check mark FC flows, FC Ethernet, storage host, etc. Everything. Click apply. Performance collection must restart when modified. Restart the performance collection. Yes. So it will take 15 to 20 minutes. And after that, we can go and check the flows and other stuffs as well. Correct. So meanwhile, again, let me quickly summarize you that you can see that in the dashboard, you can see the summary, network, storage, SAN, insights, and compute. So it's like collection of all data center components in one place. That's the power of DCNM. Then inside inventory, you can see that you can discover the LAN, SAN, storage, and other virtual machine manager in monitor. That's the key here. See, switch, SAN, uh, everything is there related to SAN. If you go and click vSANs, so you can see that you have the vSAN. By default, vSAN 1 will be configured. And if you go and run the CLI command like show vSAN, it will tell you. Even it is telling that member is edge 1, core 1, edge 2, core 2. So you have the fabric group, fabric edge 1, etc. And it's like that. Let me quickly show you other stuffs as well. So if you go and check regular zones, okay, let me show you something that it should show. So if we go and check NPV links, still it is populating, but anyways, we'll go and modify all these things later on as well. And port groups. Okay, so what I will do here, let's give him some time, and we'll come back and we'll check some other stuffs related to monitor as well inside this SAN. Correct. Then you can see the configuration. We have to do few of the configuration in our lab, so you'll understand. But it's very straightforward. That's the thing I like about GUI. So see, switch backup, archives, network config, audits are there. Everyone is looking for audits and other stuffs as well. Great. So what I want to do here, let's just stop here. And in the next section, we'll continue with our basic labs. Okay. So let's stop. In this session, we are going to perform the lab task related to port channel and joining. So let me quickly log into the DCNM. We are inside DCNM, and inside DCNM, what we can do here is, you can see that we have the configure tab. You can go to the configure. Inside that, we can check the port channel, click to the port channel, and now we have the option here. So create the port channel. Yeah, we want to create that. And we have, you can see that how easily we can go and create. So we have the workflow here, and select the switch pair. Yes, I want to select the edge 1. and core 1. This, then we can go to the next. Now what we want, which interfaces we want, we can see they selected. So already 1, 2, 3, 4. So FC 1/3 up to 1/6, they are selected, and we want to bundle them. So I can click next. And now here you can see that we can go and give the channel ID for edge and core. So for example, for edge, I will give 111, and for the core, I will give 112. Description to core, description to edge. Speed auto, but you can see that we have option. Trunk mode, what you want non-trunk, you want trunk or auto. This also I'll make as auto. Port vSAN is vSAN 1, and that's okay. I can click finish here. And now converting ISL into port channel may be disruptive. Okay, yes, I want to continue. And behind the scene, it is working. Meanwhile, what we can do, so the all action completed successfully. We can go to the monitor, and inside monitor, you can see that we have the port that we can go and check. These are the port monitoring. Great, but before checking this thing, let's go back to the CLI. And here, if you can go and check the port channel. So port channel database, and here you can see that we have port channel 111. This is active, mode is on. You can see the ports. Likewise, if we can go to the port core 1 and database, you can see that this is got formed. Great. Now we can go and check the port channel configuration. So these configurations, you can see that the mode is E expansion, description, rate mode is dedicated, trunk mode is auto. These configuration it has done on behalf of us, and these are the interfaces, correct? And you can see that the power of actually the interfaces are FC1/3 up to FC1/4. Okay, simply one command, channel group 111 force, and then you can check the configuration over the interface. That's the port channel interface, correct? So this is the way that you can easily configure it within within even within minutes. We can configure it. Let's go back, and in the monitor section, let me show you that we have the ISL. We can go and check ISL interswitch link and ISL traffic and errors. Now you can see that we can check all these details here, correct? Now you can go and check the vSANs we have checked. FC ports. Yeah, so now you can see that it is coming here, and we are going to use this as well in our zoning section, in this in the same section in the other lab that we are going to perform zone. We know that zone is very much similar like ACLs, where you have source and destination. So here we have the initiator and target, server and storage, correct? So you can see that we have the pure storage as well, whose WWN you can see. Then you can see that you have edge. Obviously behind the edge we have the compute, correct? So we have the initiator and we have the target, and we want to create the zoning. So for that, we can again click to configure. We can go to the SAN. Inside SAN, you can see that you have the zoning. Click there. Now one page will come where we have to go and select everything properly. So once we are here, what we want to do, you can see here that I want from edge 1 to core 1. That's my connection. And you know that we have vSAN 1 configured. So that's okay. Great. So for this, we can go and define the zone set, correct? So zone set, zone, you can see the different uh, sections we have in this page, different fields are there. So here you can see that we have the zone set, zones, zone member, and then the endpoint. I can see here that if I go to H2, let's wait, two switches, core 2. Because some configuration changes are there in edge 1 and core 1, so that's why I'm not seeing the edge, the compute and the storage. But here I can see the initiator and target that we can use it, correct? So let's just stick with this. We want to create the zone set, and then we want to go and add everything here, correct? So let's do it, and let's add it in one place, all these things in one place. So let's do it and create the zone set first. So this is the zone set 1, create. Then I'll go and create the zones. This is the zone 1, create. Now we want to add the zone members. So before adding the zone member, just check mark this. Then zone member. Okay. Now for zone member, create and add. Now what we can do here, that we can add the zone member from the bottom, correct? So you can see in the bottom, we have these members. You can select this, storage and your endpoints. Here you have this green button, add the members. So you can see that you have the members added. How easy this is? It's quite easy, correct? So now we have the zone set. Now we have the zone member. What we can do here is that we can go and click activate. So difference responses from server contains no change. Okay. Activation zone set difference, no problem. Activate. That means that it should go and push the configuration from running to a startup. Zone not present. This IP activate one from switch. There's some configuration changes that I have done. So that's why it is showing some problems. Yeah. Okay. So you can see here that I need to add the zone. That's adding the zone. You have this button here. And I think rest things are okay. Okay. Great. So click add, activate one more time. Yep, now it is okay. Now it's good. So now your zones are present. Activate this. And anyways, but if you go and do the configuration with respect to the CLI, I will show you the CLI configuration as well. Still, you can see that it is faster than CLI. So now our zoning is configured. Now we can go log into the devices and we can verify this, correct? Even we can go here to the monitor, and inside monitor also we can go and verify, correct? So let me see here the port, FC port incluser. Let's go and check the SAN and the ISL. What we want to see here is that we want to see that the initiator and target, they are mapped. Here you can see that you have your port channel. It's showing like this. Okay. So regular zones. and showing inside a regular zone. Okay, I'll come back to this point because we are checking parallelly and we are configuring it as well. So we can go and check edge 2. Inside edge 2, you can check the zone with vSAN 1, and I can see zone name zone 1 vSAN 1. Your members inside the zone, you can see the zone set and your zone set activation. So that's 100% correct. Zoning is correct. And then we can go and check on the other stuffs as well. Status, if we have, and for vSAN 1, show zone status for vSAN 1. This is all the basic merge control. That's all. That's also okay, but you can see that how easily we can go and do this. And for vSAN 1, yeah. So yes, if you go and give some device aliases name, you can see the name as well, but we can see that the configuration is working here. Nice and easy, very easy. You can do the configuration. Once you do the configuration from CLI, you can go and verify as well. Go here and let me see here why it not showing inside the monitor and regular zones. It should come up now. So you can see it took some time, but now it is showing that your the group vSAN zone set zone switch interface WWN port name members, everything it is showing. Okay, so clearly you can see that how easily we can create the port channel. Once we have the port channel, then how easily we have created the ISL. We have created zoning as well. So first you have the port channel, you can see the members and all. And this TCNM tool is really good. And that's why I can see nowadays is quite demanding this particular management tool, because you have good amount of data center things that you can do here. All right, so we are good at this point of time. We can go and stop here. This section we have to learn about FCOE, fiber channel over Ethernet, and we'll go and check the architecture and end-to-end deployment, means each and everything that we have to counter in this. So first of all, this technology is termed as a FCOE, fiber channel over Ethernet. An important point here is that there are a lot many enhancement in this technology. So now it can support priority-based flow control. And again, if we go and check upcoming slides, we'll find that we have new term like CNAs, converged network adapter. So what is happening here, that we know that the fiber channels, they are supporting HBAs, and normal NIC, they are supporting is for normal Ethernet traffic, we have the NIC or VNIC. And for fiber channel, we have the HBAs or VHBAs, correct? Now, HBAs and NIC, they are converged inside the converged network adapter. And this technology actually is termed as a DCB, data center bridging. Now, this is going to give us capabilities that not only that we can work with the Ethernet traffic, so we have the support for lossless transport. We know that fiber channel is lossless since we are doing the encapsulation. So what we are doing, that we are taking the fiber channel frame and then we are encapsulating with Ethernet, and then the transport is happening. So the source and destination. So if I show you the diagram, so here you can see the architecture. So you have the source, that's again the server, and then you have the destination, that is the storage. So source and destination, they are supporting fiber. But in between the transport that we have, that is Ethernet capable as well. And that's why this is FCOE, and this is the overall architecture you can see. So what are the key components we have here? Key component, obviously we have the server, but one of the important thing that is going to play, or one of the important point we have to understand, is about the converged network adapter. In this example, upcoming slide, I'm going to show you about QLogic converged network adapter slides, and we'll go and check different type of aspects of that, means what type of GUI support and how it is working behind the scene. Okay, then you have the converged network transport, means you have your Ethernet transport, and then finally you have the destination. Correct. Let's quickly see that what benefits that FCOE is offering. So here you can see that although there are good amount of benefits, I have highlighted four important one. So first of all, it is coexisting with the FC and Ethernet. So that's why it provides a smooth transition path. Okay, suppose if you are moving from FC to FCOE, so we have this smooth transition path. Then 100% application transparency for a smooth, for both the storage and network application, eliminates the need to rectify application. Okay, so transparency is there in the application performance, etc. Then high performance comparable with existing FC. So FCOE has higher performance than FC. The transition is a smooth, 100% application transparency we have. Uh, and again, here you can see that we have the increased speed. So speed is high, and that's why it is preferred, means FCOE has benefit over FC. We have application visibility. The migration approach is smooth because anyways, you are not doing major change, but you are doing minor change, correct? And finally, the management framework, including FC joining network accesses. So those things are still there. So it is compatible. We know that with FC technology, we have joining, we can create the aliases, we can create the network access control, etc. Joining is nothing but the access control in the FC. So it is not providing the feature that we have in the FC, but the newer enhancements as well. And that's the reason that FCOE has upper hand with respect to FC. Okay, so what we have discussed in this particular video is that we have benefit with FCOE, and the benefit in terms of that we have the FC as a source and destination, but transport we have Ethernet. While we are doing this approach, we have application visibility, ease of management, enhanced speed, etc. Means in the migration also these are easy to migrate. Okay, and then we have seen one of the logical diagram here as the architecture design for FCOE. Great. So let's stop here, and in the next section, what we'll do, we'll go and learn about the CNAs. In this section, we are going to discuss about the CNA, and one of the examples that I have taken for this course is QLogic 8100 CNAs. Now these QLogic CNAs are high performance, and they have good amount of features capability that can support FCOE. So let's check all these features one by one. First of all, they are supporting 10 Gbps enhanced Ethernet PCI Express, you can see. And then these CNAs provides a single chip FCOE. So that's one of the capability that we have with the QLogic 8100. They are high performance. They have FCOE offload support. So they are not putting much pressure on the CPU. Then they are supporting N-port virtualization, that is NPIV. Apart from that, other supports are also there. They have two full stack NIC options that they're having the Ethernet stack, and they're having the FC stack as well. So what does it mean? That let me quickly show you this. Here you can see that the operating system, they have the network or the NIC stack. So you can see NIC driver and network stack, and then you can see that it has the FC stack as well, the storage stack as well. Okay, so let's quickly summarize here the top points related to QLogic 8100. So the important points here is that they have the enhanced Ethernet PCI Express. They are high performance. They have FCOE offload to enhance the performance. They are supporting NPIV, superior reduced power consumption, just one third in this generation of CNA. So again, if you go and compare with the first generation and second generation CNA, then you'll find that they have improved a lot. And then they have the compact form factor, fits in blade server with high density storage. So they are compatible with high density or fast storage as well. Okay, so these are the important points related to QLogic. Now, we know the architecture. So we have the architecture here. In this architecture, how we are going to fit the new CNA, and then obviously once you fit it, then you have to boot as well, how we can go and track the CNS. So for that, first of all, in this diagram, you can see that you can go to the NIC properties, so device manager and NIC properties. You can see that we have the network adapter, QLogic 10 GB PCIe Express, that's the Express card, and then we have the QLogic FCOE. So it is showing everything is up and running. We can go inside the device manager, we can verify it. Now suppose if you want to do the installation of CNA, what are the things we need to counter? First of all, power off the server, seat the CNA properly, then refasten the CNA brackets, means connect the hardware properly. Then this CNA, so if we go and check the diagram, the architecture diagram overview, suppose if it is connected with any upstream Nexus switch, so you have to go and connect the interface with the up interface transport, whatever transport we have. In this case, for example, Nexus 5K. So connect it properly, means seat it properly, connect the brackets properly, connect with the network, and then it's ready to boot. Now the CNAs, they are supporting boot from SAN as well. So that means the operating system, so you have your operating system and then you have connected with CNN. They are nothing but the communicator. So in between the FC and FCOE, you have the communicator called CNA, Converged Network Adapter, correct? Now, with respect to Converged Network Adapter, we can go and do the boot from SAN. But first of all, what we need to do, we need to bring up the CNA adapter itself. Once the CNA adapter is up and running, we can go to the SAN server. Here you can see that we have different dashboard for the QLogic adapter SAN server. Inside that, you can go and check each and everything. So if you want to go and check and even want to change the settings related to QoS, we can go and do. If you want to check the settings related to virtualization, we can go and do. If you want to go and check the settings related to FCOE, we can go and check. Correct. So first of all, we can go and check the overall dashboard, how it look like and what are the things we have. So here you can see that model name and port name. So not only the model name and port name, but we are interested with the serial numbers as well, because for tracking purpose, monitoring purpose, we need the serial numbers as well. How many HBAs instances we have, that also we can check uh, inside the information page. Okay, great. So here you can see that the CNAs, what are the steps to go and connect to the, first of all, to the server and then connect to the network. Once you connect to the server and network, then we can go and check the CNA, that's the SAN server, one of the dashboard for the CNAs, and we can go and change the various parameters as required. For example, QoS setting we want to change, or FCOE settings we want to change, we can go and do the changes. Okay. So this slide is simply that it is supporting boot from SAN. So the steps are that once you have the connection with their storage and the Nexus 5K, then my servers, they are ready to boot from SAN. And why they are doing? Because the CNAs, they have full support related to NIC taming, NPIV, access control, virtualization, everything. Okay. Once you boot, it will show you like this. All right. So now we can stop here, and in the upcoming sections, we will go and start learning about the nexus items as well. So we have to go and learn about the network, about the medium where the actual communication is happening. In this section, I'm
Yes.
going to show you step by step that how we can go and configure FCOE. So in our topology, if you go and check the topology, you can see it's very easy and straightforward. We have Nexus 5K in between, and that is working as a transport. Now this Nexus 5K, we can see that one interface is going towards the target. Here I have my storage area network, and one interface is going towards the server, that is the initiator. So in between the server and in between the storage, how we can go and configure our Nexus 5K, what are the interfaces, what are the modes, each and everything I'm going to explain. Suppose if you go and console to one of your Nexus box, and interesting thing, a good thing here is this, that if you go and configure one Nexus, same as you have to go and configure the other box as well. Okay, so if you understand the configuration in one device, replica can be copied and pasted to the other device. Okay, so let's learn. Now what you need to do, first of all, if you're doing day zero configuration, you can go and console it. Once you do the console, then you have to give the management IP and the management gateway IP addresses. That's it. You can log into your device. You can do the basic setup. You can go and give the management related configuration. You can go and give the VRF management related route as well. So out of band management configuration and SNMP, the reason behind is that we can manage the device remotely as well. Okay, great. So that's the first thing we should do. After that, since we have to do the configuration related to FCOE, so we should go and enable the feature called FCOE. One small command, feature FCOE, and we should do this in both the Nexus 5K A and Nexus 5K B. So both places will go and enable the feature FCOE, and then we can go and check our licenses as well. We should have license package which should support FCOE. Okay, great. So from here onwards, I will show you the configuration related to FCOE, the full configuration related to FCOE. Again, you can refer this topology. First of all, we'll go and create the VPC here inside this Nexus box. And with respect to VPC, if you want the lab configuration related to VPC, you can go and refer the previous section where we have done the configuration related to Nexus VPC, and we also have Nexus 5K box. I have done the configuration and I have shown the result as well. Now, just focus on the interfaces. So one interface 1/16 going towards the storage, one interface 1/1 going towards the server, and then we have the peer link as well, 19 and 20. So let's quickly check the VPC related configuration. We need to go and enable two more feature, LSCP for port channeling or bundling. VPC, obviously we want this virtual port channel configuration. Then we have baseline configuration related to VPC. Set the domain, give the peer keep alive destination, what's your port channel, and define your peer link. So in between 19 and 20, we have the peer link where we can go and allow certain VLANs as well. Straightforward, we have done this earlier. Now, once we have the VPC, means peer link configured and VPC domain defined, then we can go and define the VPC, that's the member link configuration. So again, one interface is going towards the server, that is 1/1, where we have a VPC1 in this case, and 1/16 is going towards the server, towards the storage. This is towards the server. So one interface is going towards the storage where we are defining the port channel 16, VPC 16. So let me clean this stuff. Let me quickly show you that how this stuff look like. So how it is, this is something that this portion I am defining VPC 16, and this portion we have a VPC1. Okay, why it is important? Because in the upcoming section you will see that we have to do the mapping as well. So step number 3.5, what we are doing, we are doing the configuration related to VPC. Once VPC is done, I will go and create a vSAN. So generally we are creating two different vSAN. So for Nexus 5K1, we'll go inside the database, vSAN database, and create vSAN 1000. Likewise, we'll go to 5K2 or 5KB. There we can go to the database and create 1001. So 1001 at 5KB and 1000 at 5KA, because when you are going from initiator to target, you should have multiple fabric way to reach to the target, to reach to the storage. And suppose if one portion is not working, you should have the failover mechanism that you can reach via the alternate path. Okay, again you can go and verify with show vSAN command your vSAN configuration. So we have done 3.5, we have done 3.6. In 3.5 we have enable uh, actually 3.4. So enable the FCOE in 3.4. Then 3.5, we have done the configuration related to VPC. Then 3.6, we have created the vSAN. Okay, great. Now, very important configuration we have to create the VLAN to vSAN mapping. So what we can do, we can go inside the VLAN. Once we are inside the VLAN, then we can map the FCOE. So here you can see that the mapping of VLAN to the vSAN, FCOE, vSAN 1000. Likewise, we can go to Nexus 5KB, where we can go to VLAN 1001, and then we can map with the FCOE vSAN 1001. So one place we have 1000. Just keep in mind that one place you have 1000, one place you have 1001. So VLAN 1000 will map to vSAN 1000, and then VLAN 1001 should map to vSAN 1001. Okay, and if I have the configuration in the back, I can show you that. This is configuration related to A. Likewise, you can go and do the configuration related to B. As I told you, that other side you can go and create the configuration like this. The 1000 and 1001. The rest of the things are almost same. No change, nothing much. Then again, once we have this configuration, uh, that is LAN to SAN mapping, then we can go and verify as well. So in Nexus 5K1, you can see that show VLAN FCOE, the status is operational. Great. Again, you can see that in Nexus 5KB, we are mapping 1001, that's the VLAN, to the 1001, that's the vSAN. 100% same configuration, just the numbering is a little bit different. And there also we can go and check show VLAN FCO. Four more steps we have to do to complete the configuration. So we need to create the VFC for the initiator and VFC for the target. While creating the VFC for initiator, you can see the configuration is straightforward. We have to go inside the interface VFC1, and remember that VFC1 is for the server who is our initiator. So VFC1, and we are binding the interface with the port channel 1. So we have the topology diagram where we have 1/1, where we have created the virtual port channel here, correct? Now we are creating a virtual fiber channel, and this virtual fiber channel we are binding with the port channel 1. Likewise, for the target, we know that we have 1/16. There we have the VPC, virtual port channel. So indirectly we are creating VFCs, and we are mapping with the port channel 16 or virtual port channel 16. Correct. So something like behind the scene, it is VFC to VPC mapping, or the port channel or the fabric to the ether channel mapping. Correct. Now we have only two more steps. to do the configuration. So next step is that add the VFCs to the vSAN. So we can go to the vSAN database where we have vSAN 1000 for Nexus 5K1, vSAN 1001 for Nexus 5K2. So we can go to the vSAN database where we can map both the initiator and the target. Um, More precisely, we can map both the virtual fabric channel, and we have the initiator and the target in the same range. So we'll can go to the database and we can go and map the source and the target, correct? So source, your server, and target, your storage. And now we are very much done. So the last step is only that we have to go and create the zone and zone set. Why? Because we want to control the boot from SAN, or we want to control our fabric. So for control mechanism, we should go and create the zone and the zone set. So here you can see that first of all, we can go and check the Floggy database. So from there, we'll get the worldwide port name. And this also we have discussed a lot earlier. Now, once we get those login details, then we can go and create our zoning information, or we can go and create our zone related configuration. So what we need to do here, we can go and create the zone name FCOE zone with the vSAN 1000. And again, replica can be done inside Nexus 5K1. So inside Nexus 5K1, if we have 1000, so Nexus 5K2, we can go and give 5K, we can go and give 1001. So 1000 and 1001, we can go and put like this, correct? So you can see the configuration that we can go and create the FCOE zone where we can go and put the port worldwide node name. Then we can go and give both the initiator and the target information. So we will create the zone name, we'll put the initiator and the target. Then we have the zone set because we want to activate the zone set. So only 4 lines of configuration. You can see line number 1, create the name of the zone, put the members, correct? So that will be your line number 1 or line number, step number 2 or line number 2, 3. Then you have to go and create the zone set. So we are creating the zone set in Nexus 5K1. We have vSAN 1000. So once we have the zone set, then again we are going inside the zone, that is the FCOE zone 1, and then we are activating the zone set. So zone set activate name FCOE vSAN 1000. That's the final command to activate the zone. And once we activate the zone, we can go and always verify with the configuration. So zone set activate for that particular vSAN. So this is the way that we can go and do the complete configuration related to FCOE. And what are the steps involved? Let me quickly summarize. So in 3.4, we went and we have enabled the FCOE feature, correct? Then in 3.5, we went and we have created the VPC, virtual port channel. Then inside 3.6, we went inside 3.6, and then we have created the vSAN. Remember, for Nexus 5K1, the vSAN was 1000, and 5K2, the vSAN was 1001, correct? Then inside 3.7, what we have done the mapping. So we have done the mapping for the VLAN, actually the FCOE mapping with the vSAN, correct? Then inside 3.8, what we have done, and 3.8 and 3.9. So we can think this as a combined. We have done the uh, initiator and the target VFC creation. Okay, so we have created the VFCs for the initiator, that was interface 1/1 and the target 1/16. Correct. And after that we have, so let me clean here. So we have 2 more steps. We went inside 3.10. Let me show you. So where we have add the VFCs to the vSAN because we need it. So inside the vSAN database, we have added the initiator and the target. And in the final step, we have to create the ACL type of entity, means we want to control the fabric. So in the final step, what we have done, we have created the zone and zone set. And then finally, we have activated the zone set. So this is the complete configuration related to FCOE. And let's just stop here. And next section will continue from here. In 3.3, we have to understand about NFS, Network File System, and NAS concept. So let's try to understand NFS and NAS concept. Now, before going there, we should know that what type of storages we have. We have three major type of storage: block storage, file storage, and object storage. Now in this section, I'm going to describe two of the storage because that is falling under our subsection 3.3. I'm going to explain you about the block storage and the file storage. Again, we are going to focus on the file storage because in 3.3 we have to understand about NFS concepts associated with a NAS. So let's understand that. Let's first of all take a look inside block storage. Now, what is block storage? Again, for block storage as well, you have some attached storage. Maybe you are attached with the storage area network, or maybe you have the tape or drives. Now, in any of the use case, the way that the storing is happening, so it is using the atomic unit of stored data. So this means that you can still go and store the data inside the volume, inside the media. But the point here is this, that inside the server or outside the server, how the storage is happening. Key point here is that how the CPU is going to handle the store request, correct? Now, before going there, let's quickly check that what are the pros and cons we have. So pros is there that host system has direct access to the storage. There's a good thing that either you are located, or if you are a local store, or your storage is hosted anywhere remotely, still the host will think that they are connected locally, because they are not worried about what is in between, what's the transport in between. We know that you have the host, and in between whatever media you have, they will think that where is the storage. So that's the direct connection you have. Now here also, we may have local storage, we may have remote storage, but both the case, the host will think that they are directly connected. That's the plus it has. The con it has that it need heavy uh, reliance on high availability. So before this section, we have discussed that to reach from your host to server, you should have at least two fabric. So if one fabric is down, still you have one channel to reach to the destination. Correct. So that's the one very key point here. Now, the way that CPU is going to take the request, and it is going to handle the request and put that data inside the volume, it's different inside the block storage versus the NFS or the file storage. Okay, so what is happening here? 2 points are there. Inside the server, how it is happening, the CPU communicates with the file system in the order to control a volume. So CPU is going to control the volume, how it is going to store inside the storage. Same thing is happening, but if your storage is in the remote location, so still the host will think that they are connected directly. But still, the point here is that you should have high availability. Okay, so this is the block storage. Now next we have file storage. File storage is quite popular, and so many different organizations, so many different vendors, they are using file storage. Let's understand why they are using. It has good amount of feature. You can see here point A, we see topmost definition for file storage is that an ordered sequence of data type is stored on a disk or tape. So it is in order, and this order and the way that they are storing inside the storage, they have the unique reference number. Some reference value they have because they are in the ordered sequence. So that's point 1 and point 2. Now point 3 is that we know, if you are working in the Windows, we know this thing, that if you are sharing something, you can provide the permissions. So read only, read write, etc. So permissions also we can go and provide. Okay, so you can see that file storage capabilities here. It's like you can think that inside your laptop or desktop, it can work as your local storage. Correct? Either it is locally or not, but it can work like this. So, for example, if I have my laptop and I have my G drive, now we know that G drive is in the cloud, in the Google Cloud, but still I can see in my laptop that G drive is there, and then I can put the file and give the permissions inside that. Okay, great. So how this file store is working, what are the other characteristics and what are the examples? Let's quickly check this. So here you can see that this is the foundation of network attached storage. Two highly popular file system we have. One is the NFS, which is industry standard. One is SMB, which is proprietary. But still, SMB is also used 50-50%. Like NFS is used 50% of places, SMB is also used as 50% of places. Okay, great. Now let's check that what are the features we have. So these are the purpose built structured and unstructured data over one or more protocol, is scalable, supports large number of client, querying, caching, deduplication, multi-tenancy, replication, multi-protocol support, cluster NAS, and they have the petabyte scale. Again, we are talking about file storage now. Now, when we'll go and learn about NFS, the next thing that we are going to learn is a network file system. Whatever benefits we have inside the file storage, that will come under NFS. So NFS is nothing. Again, we have example related to file storage. So file storage example is NFS or SMB. That's the server message block, and both are used heavily inside the industry. Now let's quickly check this particular diagram, that how behind the scene they are working. And if you understand this particular diagram here, you will understand that who is the managing these storage. So what is happening, again the key term, what is happening as a host, the storage is local or it is somewhere. As a host, I will think that they are local. Okay, and who is the control mechanism? Obviously your CPU, who is doing the communication with the file system manager, and then uh, as per the storage, they are thinking everything is local. And again, because you have the file system manager, then you can manage the permissions, you can manage the read write permissions, uh, different type of label of management we can do. Correct? All right, so these everything that we have discussed here, it's related to file storage. Let's quickly check everything that we have inside file storage will be inherited inside NFS. So what is NFS? Let's check one by one. NFS is a distributed file system that allow user to access a remote file system as their local, that we have discussed earlier a lot. Then NFS uses client server model. Okay, so who is the initiator, who is target, like that you can understand. Then so point one, point two, point three, let's see. They are using RPC as a remote procedure call, because you may have your storage local, or you may have your storage maybe over the cloud, or maybe somewhere extended via the network. Correct? So if it is somewhere far, then they're using RPC, remote procedure calls, to reach out. Then finally, they are hierarchical in nature. They are hierarchical in nature, and yes, they can have the hierarchy as well. Great. Let's see that where and which companies they are using. So you can see here the Amazon support NFS 4.0 as the elastic file system. The VMware, they are supporting NFS version 4.1 as a client storing VMDK. And other thing is that NFS and SMBs both are popular and both are used 50-50. Great. So this was the explanation related to NFS and NAS. I hope you understand this. Let's stop here. And in the next section, we'll go and check 3.4. For subsection 3.4, that is software updates and EPLD. You can go and watch the previous recording 94, 95, and 96. What I have done that I have joined all these three files, so 16 minutes plus 13 plus 8 minutes, approx 36 minutes. And then I created one video that you can go and watch after this recording. So please watch these sections, or you can go and watch one video after this to complete this section, that is 3.4. Next, after this, once you complete this 36-minute video, we'll go and start with section 3.5 that is related to infrastructure monitoring. So far, you have seen that most of the sessions are long and lengthy because I just wanted to cover each and everything related to point 1.1 up to 1.6. This section is going to be shorter than the previous sections because here we have to understand the software update and their impacts. You can see that this section has divided into three portions ABC. What is disruptive, non-disruptive update or upgrade? What is EPLD and patches? So we are going to learn this in this particular video and obviously in upcoming videos, that what does it mean by software upgrade and hardware upgrade. And you can see here EPLD, it should come in the section C actually, and the patches should come up. But anyways, I'm going to follow the sequence 1.7a and then C and then B. Okay, so let's start with disruptive and non-disruptive upgrades. Let's start first of all with the software best practices, what we have. Now, before starting this, at this point of time, you should know that the Nexus operating system, they are following such as modular approach. So what does it mean by modular approach? Modular approach means that whenever you are using those features, say for example, any protocol, OSPF, then we have to go inside the box and then we have to enable that feature, right? Now, since we are enabling that feature, that means that somehow they are fitted inside the operating system in a way that if it is not required, you no need to do anything, correct? And now in the diagram you can see, and let me highlight as well, that what is the overall structure. This is something called software architecture of Nexus operating system. So obviously you have the kernel, you have the drivers, you have chassis manager. We are going to discuss about chassis upgrade and line card hardware upgraded as well in EPLD section. But you can see on top you have the protocols, you have L2 protocols, L3 protocols, you have storage protocols, you have other services as well. So what's key here? The key here is this segment. This is manager, PSS, MTS. Now altogether this is a big topic, and suppose if you're working as a TAC in Cisco, so you'll come to know the big picture about what is the MTS, PSS, sys manager, etc. Means when you have to go and do some sort of hardware level troubleshooting, some sort of deep troubleshooting with respect to software, you have to understand all these transactions, messages, and transaction, etc. Now here we are going to focus mainly on the topic agenda. So agenda, it is telling that describe the disruptive and non-disruptive upgrade. Okay, so before going there, I have 2-3 slides just to make our fundamental correct, make things uh, in a way that we can understood those concepts correct. So it's like we are creating the framework, and in that we'll learn disruptive and non-disruptive. So let's try to understand this. Okay, so understand like this. Suppose if you are running one feature called OSPF, and then if your OSPF will got crashed, what will happen? OSPF is one of the process in Nexus operating system which is working as one of the patch, or not patch, but it is working as a protocol, but it's the modularity. So if you go and see here, you can see that L3 protocol, inside that we have OSPF. Correct. So you have features, or you have packages, you have softwares inside software. Correct. OSPF is one feature, one package inside the big operating system inside Nexus. If it got crashed, if something will happen with OSPF, what will happen? That's the one thing. Means if your protocol start not performing, first thing. Second thing, again, this is one of the concern that you may have. All of a sudden, your protocol stop working. So obviously, what we will do, we'll go and raise the attack case. We'll try to figure out why it is happening, due to memory, due to hardware issue, due to traffic issue, or it's a bug or something. By any means, suppose if we have to upgrade the image due to any reason, maybe software end of life, maybe some bug, etc. So what we will do, because this is a critical environment we have, this is a data center. It's like you don't have any downtime. That means if your switches, your core switches are down, or they are rebooting, or they have any issue, that means entire production revenue will go down. Correct? So in this manner, in this case, that how you will go and do the software upgrade, and what are the features that Cisco is offering, we are going to learn in terms of disruptive and non-disruptive upgrades. So one key thing here is that we should understand, and let me highlight as well as one of the key thing we have here, that persistent software service, or persistent storage service, actually this is nothing but a database, so that's why it's a storage or something. um Let me go here, and I just wanted to make sure that whenever we are talking about, oops, whenever we are talking about PSS, you think this as a database or data store. Now what is the use of database? Database means that when you are doing any transaction, some ID will get generated, and then inside database you are tracking that ID. Correct. So that's the use of PSS, persistence storage service. That it is working as a checkpoint. Suppose you are reading 100-page book, and then after uh, 37th page you put some sort of marker. That is nothing but one type of checkpoint. Correct. You're putting some green or red pages, or marker or something, you're doing it. Correct. Okay. So we understood this thing at this point of time, that PSS is nothing but a database. Now what's the usability? Usability here is that, suppose you are doing the upgrade. Correct. Your protocols are running, your services are running. There are two things, and these things I'm discussing a lot inside my SD-WAN classes nowadays in the SDN solution. So, remember, you have two things. You have control plane, you have data plane. Now, the actual movement of data is happening in data plane with the line card, IO module, etc. But you have your soup engines, which is working as a control plane. So, what will happen that if you're using non-destructive type of upgrade with help of persistence storage service, PSS or database, your data plane will keep forwarding the data. Obviously you have two soup 1 and soup 2. Again, we are going to discuss more, but your data plane will not have any issue. You're forwarding the data in the data plane, and your control plane meanwhile it's doing the upgrade. Since you have two control planes, so first of all the load will go to one control plane. So one will work as a standby, other one will work as a active. Once the standby will get upgraded, then active will become a standby, and this will become active, and then upgrade will happen until unless complete upgrade will happen. And now since there is no problem inside the data plane, so that's why it's a non-destructive. So while performing the non-destructive type of upgrade, obviously you need two SOOP. And in this case, you can see in the diagram that you have one active, one backup, and they will swap their role. Correct? So that's why you have this stateful switch over. This is one of the technique that whatever a state that the transaction or the data plane has, correct? That will be, so that role from active supervisor, it will be bypassed to the standby supervisor, correct? Again, if your active will become standby, so that role will get transferred. That is called as a stateful switchover. And for that, obviously, in terms of protocols, you have non-stop forwarding enable. You can go and enable that. You have your PSS, that's the database stateful restart, means with help of PSS, some check mark, some bookmark is happening. Correct. Now, what are the triggers for this? Triggers is obviously if you are doing ISSU, that's the software upgrade that you are doing, or you are doing some manual switchover. So suppose you have two SOOP and this is active, this is a standby, but manually there are CLI command. You want to make standby as a active, correct? So you are doing some manual command, or if your HA policy initiated, means suppose if your services are crashing and it will go, suppose if your services will crash for 3 times, then this stateful switchover will happen. Now, since we have two supervisor engine, that means it is non-destructive. There's no problem in the data plane, correct? Again, the same thing here, same discussion that we have discussed that, okay, uh, suppose if your BGP or OSPF will get crashed, you have the marker, you have your PSS who's doing the marker, but you have high availability manager as well, HA manager as well, correct? And with help of HA manager, high availability manager, the switchover will happen, and there is no problem because behind the scene the PSS is working. It's doing the marking while doing the switch over, a stateful switch over, the PSS will exchange the state. Okay, so we are talking about ISSU. The functional role here with the ISSU in service software upgrade is that they will provide the capability to perform transparent software upgrade on the platform with the redundant supervisor. So this is the key. Whatever we have talked earlier in last 10 to 12 minutes, this that you can highlight this important line. And for the interviews also, it's an important thing. So ISSU you are doing, you should have the redundant supervisor. If you are in the Nexus platform, Nexus 7K, 5K, etc. Let's talk mainly on Nexus 7K when you have the modular box with two supervisor engines. So in that case, you know that you have two different type of image. You have one system image, you have one kickstart image, correct? Now you can see system and kickstart. Here in Nexus 7K, when you have the two supervisor engines, still when you are doing the upgrade, you can give one CLI command. So install the kickstart and then the boot flash your image name, and then the system boot flash your image name. Correct. So this upgrade will be taken care. Great. So far we are talking about the non-disruptive upgrade, and before moving to the disruptive upgrade, let's do the summary, whatever we have studied. So we are doing in-service software upgrade. We need dual supervisor engine to do the failover or stateful switchover. There are three techniques, and assuming that we are doing ISSU upgrade, means we are initiated the ISSU. So what are the steps? You have step 1 to 7. First of all, upgrade BIOS on active, standby SOOP and line. First of all, your firmware will get upgraded. Step number 2, bring up a standby SOOP with new image. Okay, so it is upgrading the standby SOOP. Step number 3, switch over a standby task. Obviously, if you have active and a standby, so first of all, this standby will get upgraded, and then the switchover will happen, and then your active will become a standby will become active, correct? So bring up old active soup with new image. Now, once this will become active, then again this will get upgraded. Correct. So now, point number 4, you can see that all your supervisors, 2 of your supervisor will get upgraded. Then upgrade the CMP. Correct. CMP is nothing but connectivity management process. So you are upgrading that CMP. Then you are performing the hitless line card upgrade, one at a time. Obviously, in Nexus 7K and 9K, there are some different uh, variation or different way that they are doing the upgrade. But bottom line is this: that is a 7K type of architecture or 9K type of modular architecture. Both places, once your supervisors will get upgraded, means your control plane, in other way, will get upgraded, then your data plane will get initiated. Data plane is your line card, and then finally your upgrade is done. So this is the flow from point number 1 to 7, and all whatever we have discussed so far, they are related to non-destructive upgrade. Correct. So suppose if you are upgrading from 6.2, maybe 8 or 9 something, to 6.216, so it's a minor version upgrade. So in that case, you can go and do ISSU, non-destructive upgrade. And obviously you should follow the VPC best practices as well. So let's stop here, and in next section we are going to discuss about the destructive upgrade. In case you have only one supervisor engine, then what will happen? In this section we are going to discuss about the disruptive and the patches upgrade. So let's understand. So far we have discussed about non-destructive upgrade where we have two SUP. Now one question you may ask that, okay, what about the readiness? Do we have any CLI command that will tell us that how we can check the readiness of two of the SUP? Yes, there is one nice CLI command you can check. This command is show system redundancy and then status. So system redundancy status. This is one of the CLI command that will tell you that the readiness about your SUP engines and they are going to be ready for ISSU or not. Correct. So that's one very nice important command. Even if you have any issue and if you raise Cisco case, they will first of all they will run that command. Obviously you should know the image, your versions of your SUP, etc. But this is one of the command will give you everything, all the information prior to ISSU. Great. So let's talk about the disruptive upgrade. Now, suppose if you have only one supervisor engine, and this is applicable for those type of switches where you have one SUP. So in that case, if you go and do ISSU, you'll find that there will be 120 minimum 120 seconds of lag or the communication disruption in between your control plane, that's your SUP, to the data plane, that's your line card. So that disruption can be minimized or reduced if we can go and use enhanced ISSU or LXC. LXC is a Linux container based ISSU. Okay, so what does it mean? Now you can think that when we are doing the upgrade into physical supervisor engine where you have SUP 1 and SUP 2, obviously one is active, one is a standby, etc. So they are taking the role, correct? So the standby will become active, active will become a standby, they will do the stateful switchover, etc. Means they are determining the role and then they are doing the upgrade, etc. But suppose if we have only one SUP engine, so you can think that we have only one SUP or physical SUP, PS I'm writing, then in that case how you will upgrade this and this will become secondary, etc. So in that case, what will happen in this enhanced ISSU or LXC based ISSU, that one of the supervisors, you have only one supervisor engine, remember. So what will happen, virtual instance of supervisor will get created. So some sort of, you can think this is some sort of virtualization technique that will go and drastically minimize the disruption between the control plane and the data plane, and this time this will be less than 6 seconds. So from 120 seconds it will get reduced to 6 seconds or less, because obviously, when we are doing the virtualization and all, there is a lag. They need actually some hardware that is not physically assigned to them, some sort of virtual capability it required. Now, while doing this, we have to go and set boot mode as a LXC, and then you can go and save this. So that's the one very important thing. Now, when we are talking about a Nexus 9K platform, they are not like Nexus 7K platform. And when we are upgrading Nexus 9K, they are doing the upgrade in patches. They are doing upgrade in groups. That's the correct word. So they are doing upgrade in group. That means that you can see here in the list that 1 to 6, when we are doing the upgrade, first half of the line card will get upgraded, then first half of the fabric module, then second half of line card, then second half of fabric module, then first system controller, we know what is SC and all, then second system controller. Correct. So they are doing some sort of parallel upgrade process. So not only that 9K is supporting virtualization, but it is supporting parallel processing as well. And that's the innovation. We know that all the time Cisco is keep improving their product, and whatever best latest in the market they are using inside their products as well. Great. So next thing that we have to learn here in this session is the patches. So let's try to understand the patches. Now, we have decided that we have to do ISSU due to any reason, due to software crash, due to some limitation, due to some feature, due to bug, etc. Any maybe Cisco tag has supported. But what about that you have to do the upgrade and you don't have the downtime? Now the question here is this, that you want to do upgrade, but uh, uh, but and again it's the important thing, but your devices, your data center devices, they are hitting just one bug, or they are hitting they are hitting some bug in a way that it's not critical bug. Correct. Now even if it is a critical or as well, so there may be use cases, maybe it is a critical bug, correct, but you have very less downtime. Means even the bug is hitting you, but you know the severity of the bug, but you don't have downtime. You have downtime less than 6 seconds or less than 10 seconds. Correct. It's very difficult for you as a data center engineer to get the downtime, because once you tell your manager, I want to upgrade, I need 10 minutes of downtime, then war room will get a start, everyone will come on call, and why it is happening, it was not happening, etc., etc., etc. So many things. So now, doing the full upgrade, correct, we can go for SMU, or we can do some patching. SMU is nothing but the patching. So what does it mean? SMU is nothing but software maintenance upgrade. So suppose if you have any critical bug that is hitting your platform, you can go and raise a tag case that tag case, you have this bug, do you have any SMU, or tag will suggest you, see, do not do full upgrade. We have the patches, we have the software maintenance upgrade. So as per the running image, plus as per the bug that hitting to this image, this is the SMU that they will provide you. So in that case, it's again hitless type of upgrade. You can do the SMU, and again we'll see that the life cycle and the usability. But we'll go for a small patching rather than go for complete operating system upgrade. Okay. So now, first of all, let's see the SMU or the patching life cycle. Here you can see that we can go to the Cisco side. We can select our operating system and the critical bug. According to that, we can go and select the SMU or the patch. Now that patch we can copy to our device with install add command. So once it is copied to the operating system, means not operating system, but once it is copying to the device, correct, memory and process inside the device, then we can go and activate that. So that's once you go and activate that, that means it's ready to move. And then finally, once you commit it, then it's performing. Means now this is patched with the operating system. So OS plus SMU. Okay. So now you have your patch ready, which will fight the critical bug. So you must need the install commit. Now, due to any reason, after some time in the future, if you want to deactivate that, so you can go and use the install deactivate command, so that SMU will get deactivated, but still you have to do the commit. Okay, so commit for activate, commit for deactivate, and finally, if you want to throw it in the garbage dustbin, so you can go and do install remove. There are some show commands as well. So install active, committed, inactive package, package info, etc. Just to verify that your package is having these features, capabilities. Now, let's quickly discuss about the different type of SMU. So there are others as well, but two main one is the restart SMU and ISSU SMU. So in-service software upgrade SMUs are there. That means that patches will work as ISSU SMU, either it's a dual soup. So you have to follow the ISSU process. If it's a single soup, you can go and reload it. Correct. Then we have the restart SMU as well. So this will go and restart the process, and it will go and restart the VDCs as well. So process restarted in all VDC we're running. Again, what are the important point? Cannot patch to the next release. Patching is not available per VDC. So like suppose if you have 4 VDC, um, you have to go and enable it to the admin or default VDC, correct? Per VDC feature is not available. You don't need to apply all the patches, correct? So there are obviously patches 1, 2, 3, 4, whatever. You don't need to apply all the patches, but very important that suppose if you have to use P2, but before P2 if you have to install P1, that means if P2 has the dependency on P1, then you have to go and install the P1 and then P2, correct? So some SMUs may only have single fix, other may have multiple packages. So some dependencies there, but the thing is there that you should understand about SMU, and when if required, obviously Cisco supports are there. You can go and raise Cisco case and tag case, and they can work as a proactive backup for you. Great. Finally, SMUs are tag supported. That's why I told you that tag support is there, and you should utilize it whenever we are upgrading in the data center. You should have one proactive case going on with tag. Then SMUs are synced to the standby supervisor. On super replacement, patches will be synchronized. So that's normal thing. And finally, SMU are not for feature. Suppose you want some new feature in your data center. So for that you have to check with Cisco account manager. SMU is not something that is going to add the feature in the operating system. For feature specific things, you can check with your Cisco account manager and they will provide you the valid path. According to that, you can get some other images with new features. Great. So we have completed two sections so far. We have completed 1.7a, disruptive, non-disruptive in the previous section. Then we have completed C, that's SMU or patches. Now next section we'll go and learn about EPLD, and that's also very interesting and is related to hardware upgrade. In this subsection, we are going to discuss about EPLD. And this is important because so far we have discussed about the software upgrade. What about hardware upgrade? And first of all, what is this EPLD? Now you can see this is a big full form of EPLD is electronic programmable logic device upgrade. In short, EPLD is nothing but the ASIC. So what about the ASIC upgrade plus the hardware upgrade as well? Now, while we are doing the hardware upgrade, uh, that's intuitive, correct? That means we need the downtime. So be mindful that when you are doing this upgrade, you need downtime of at least 30 minutes. And then if you want to check that are you ready to do this upgrade or not, then you can go and run this command, install module 1 EPLD boot flash and the image, correct? Uh, Obviously, you want to install it, then you can go and press yes to continue, and then your installation will start. So what are the key things here about EPLD? Is nothing but your ASIC. It's now we are thinking about to do the ASIC upgrade. We want a new type of ASICs placed inside the data center who can support new features as well. Again, this will come with lots of planning, because whenever we are doing hardware upgrade, this is equals to cost as well. So it's a cost effective upgrade, and obviously you should have uh, multiple emails from your managers, from your director, etc., that you have approval from this. Once you have the approval, means it has its own life cycle. So the requirement, then the cost estimation, then the approval, then the hardware will come to your location, and then you take the downtime, and then you will do the upgrade. Correct? So each and everything will be linked here. Again, continuing to this hardware upgrade, there are multiple things, or there are multiple types of hardware upgrade. You want to do the line card upgrade. So suppose if you have M1 line card, and then if you have F1 line card, means anyways, if you have mismatch of the line card. So at that time, what you can do, although we have this online insertion and removal of line card, means, yeah, you have this hard swap option or hard removal option. You have soft removal option. Means, what does it mean? Simply, if you go and take out the module, take out the line card, so that's the hard type of reset or removal. You can think like this. Soft means you are doing some software command, and then you are shutting down that module, or you're shutting down that interface with the CLI command. That's your soft type of removal, or giving the instruction. Okay, so considering this fact, what's the important thing here is this, that OIR is supported for the line card, but it's not recommended. What Cisco is telling, that suppose if you have to remove and upgrade the line card, so what you can do, first of all, you use this command, out of service module, remove it. Okay, then put new line card inside the slot, and then start the upgrade. Now there is one hidden command. You can see that if you are in the mixed VPC mode, the hidden command is go to the VPC domain and use bypass module. Let me highlight this. So here you can see that you have this bypass module check. Means you are, if you have the mix of the hardware or line cards, then you are bypassing it. Still your VPC domain, it will understand. But once you complete your removal, once you complete your migration, then go and remove this command. This is not recommended. And obviously you can take suggestions from Cisco TAC as well, that you have this situation, and you need to perform such type of upgrade, and kindly verify this internal command as well. Okay, great. So what type of hardware maintenance you will find? You will find that supervisor hardware upgrade, correct? And we have discussed about this as well little bit in previous section, when we are doing ISSU. That's a software upgrade, means you are not changing the physical thing, physical entity. But suppose if you have some old supervisor and you want to change, put new supervisor, then how you can do it, correct? So that will come into your major hardware upgrade or maintenance, and then you have to physically remove it and insert it. Okay? So you should follow the proper life cycle, because you are changing the control plane. So what type of hardware upgrade will come into the picture? Obviously, the supervisor hardware upgrade, correct? Again, you have option that you have two supervisors or you have one supervisor, because we know in case of one supervisor engine, again, in ISSU we have discussed that if you have one supervisor engine, how you can do enhance ISSU, etc. But again, you can see that they are linked. So you are doing hardware upgrade, and in future after 3-4 months, if you have to do software upgrade as well, so you can use EPLD, you can upgrade your firmware, your hardware, and in future again you can do ISSU or other methods to upgrade the software. What other use cases we have? We can go and do complete chassis hardware upgrade, correct? Then we can go and do fabric module hardware upgrade. Again, these upgrade will come with the issues. These upgrade will come with the suggestions. If you have major issue, if you have much load on the data center devices and you want to uh, increase the fabric module, you want to increase the port density, module density, etc., they will come with the use cases, and then you have to do the hardware upgrade, correct? So suppose in case of fabric module hardware upgrade, you should check that your fabric utilization is how much, because once you take the redundant fabric module, obviously if you have two fab module and you are taking one fab module out, then obviously in one fab module the load will increase. So before doing the upgrade, and you don't want the disruptive upgrade, correct? So before doing the hardware upgrade as well, you should check, you must check that what is your overall utilization in case of the fabric module upgrade. The same thing will be true with the power supply hardware upgrade as well. While you are doing the power supply hardware upgrade, suppose if you have 4 or 5 slots related to power modules, then if you are removing one power supply hardware module, what will be overall weight to rest of the power module? And in this case, what we can do that we can check the environment power, and then we can estimate that if we are running this power slots, suppose in combined mode, and that should be recommended that you should run in the combined mode, because you are removing few of the power module and then you are doing the hardware upgrade. So during the migration, what commands will be supported, and after the migration, what command you want for the optimization, correct? So each and everything should be written down and taken care before doing the actual EPLD. All right, great. So we have completed section 1.7. This is the last subsection where we have to understand about overall infrastructure monitoring. Now, we have one tool called DCNM, and we have discussed about that tool earlier, that with help of DC data center network management tool, DCNM, we can go and manage overall DC infra, correct? And I have shown you in the lab section as well that what options we have, and with help of DCNM, we have deployed our storage as well. So here you can see that with the help of DCNM, we can go and manage the underlay overlay, we can do the monitoring migration, and we can manage the compliances as well. I'm going to walk you through that what are the features we have with related to monitoring. Actually, we can do the monitoring, maintenance, and troubleshooting. Once you do the day 0 deployment, then you can go to day 2, where you have to manage the day-to-day operations, and then you can manage with help of DCNM. So the first option that we have here inside DCNM is the topology, that where we can go and get the real-time network view. We can go and do the real-time search. We can check the health score, color. We have the link pop-up, we have the layout option, and we have the individual dashboard as well. Now, such type of feature we have with almost all the management platforms, such as SD-WAN we manage, such as DNA or DNA Center, even ACI as well. You can have this robust type of display. Now, DCNM, the good thing about DCNM is that it's very easy to use, and you have to go and click. If you know the overall technology behind the scene, then you have the GUI and you can go and click and you can manage, monitor, etc. Now, second option here, you can say that we can go to the device maintenance where we can raise the RMA. We can discover the device, discovery of device we have done earlier. It is telling you about the device option, the device roles and the modes. Correct. Apart from that, we can go and check the history as well, where we have the configuration status history, device level deployment. Okay, so you can see the first screen is related to network view, real-time network view. The second screen is related to device management. Again, point click, you can go click and you can manage it. The third here, a third screen here we have, slide here we have is related to compliance status. Now 4 layers we have. So we can go and check the pending configuration. We can go and check the expected configuration. We can check the current configuration, and then if we have two commits, commit A and commit B, then you can go and check the difference, the comparison as well. So in this way, we can go and do the complete compliance, configuration compliance, status management, not only the management, but we have the status visibility, and obviously we can manage as well. Okay, then we have the resource management tab as well. We can go to the control. Inside control, you can go and check the device serial number, the deployment type, the fabric MSDs. Okay, it's just the scope. So overall, device inventory and the serial number and the deployment status, deployment type associated with those devices, we can go and check. Correct. So now you can see the things are getting interesting, and this is going in deep. So we can check the network view. We have the device management, the compliance status visibility. We can go and check the resource management. Then we have the configuration deployment history as well. So the switch history, the policy type, user role, deployment history. Means you have the history task as well. So who has done who has done what time, those information you will get. Correct. Next, we have the compute host visibility. We know, and we have seen these options earlier as well, that we have in data center. Obviously you have the virtual machines. So with respect to virtual machine, if you are doing the virtual networking with respect to virtual switch, etc., you can go and have the visibility inside the DCNM as well. So once we have the visibility, then we can go and check that what are the physical connected host, what is the distributed virtual switch, displays VM. You can see the red marks here, they have some issues. You can see the green marks, they are well, good and healthy. Okay, and in the bottom you can see the legends as well. So it's like that, means it's easy to use. If you know the technology behind the scene, you can go and use it easily to monitor your infrastructure with respect to DCNM. Great. So we have completed our section number 3. Now we have only 2 more sections. So let's stop here, and we will meet in the upcoming sections. Hi everyone. Thanks for listening this message. In recent times, we got messages that do we have any program, any course where we can go enroll and we will be very much eligible for the job market. What does it mean? That if you go and check the IT portals, you can see that you have different course packages for CCNA, then CCNP, then firewall, then cloud, then automation, etc. Right? So what we have done, that we created one program for those engineers who want everything at one place and they are new to the market, or maybe they want to enhance their skill set. So we created such program, Joint. Joint is something like job-oriented internetworking training. Now in this program, you can see that we have added CCNA routing switching, cloud virtualization part of VMware, CCNA or associate level wireless knowledge, Cisco Meraki, Google Cloud associate level knowledge, not entire course, but how much you need to get clear in your interview, or when you are working on this cloud environment, you are not new to that cloud environment. Then Python, then routing switching, ASA firewall, and then uh, we are adding firepower as well. So not only ASA firewall, but next generation firewall. Then we are going to add Cisco SD-WAN, Cisco DNA, etc. Like what we want, that we want to make this course as a complete package course, in terms that once you go and complete these areas, you write, you can write in your profile, in your CV, that you know these technologies. And apart from that, not only this course, once you go and use the joint 9, that's the code here, and if you apply, you will get maximum 85-86% discount on this course. So not only that we are offering the discount coupon, but apart from that, we are giving the lab, EVNG lab. So whoever will go and join this particular course, they will go and get the EVNG lab as well, so they can practice routing switching, right? So what you need a solid foundation, solid course where you can gain the technology knowledge. Then you need the lab environment where you can go and do hands-on practice. And then you can go and add these areas in your profile and go for interviews and all, right? So on other word, in simple words, I can tell this thing, that if you go to Udemy or YouTube, I have so many different courses I created just to obviously earn money. So many courses I have, but this is the only course I created actually for the IT professionals, actually for you, where I want that you can go and get the job. That's why I have added whatever I have 15, 16 years of training experience. I have added all the best things from there, in terms of that you gain knowledge, whatever gray areas you have. Someone knows networking, don't know automation and cloud. Someone knows networking, they don't know firewalling technology, security areas. So that means that you can go enroll this course, gain the knowledge on those areas that you don't know. Or suppose if you have only 1 or 2 years of experience, then you can start this journey, complete the entire course within 5 to 6 months or maybe 3 months, and then add these things within your CV profile and get the job. So this is something like job oriented or career oriented training that is going to help you to get the job and right knowledge to showcase in your profile. All right. Thanks for watching this video.